going to do a lecture or something like that.
Oh, yeah.
You could download that to the internet. You've got the full books then.
Nice. Okay, so let's get started. It is 10 o'clock on the dot. This is the February meeting of the Robotic Society of Southern California. I am Ben, the current president, and we are here at the University of Long Beach for our monthly meeting. Welcome everybody, those online and those in person. Today we have two lecturers. Alan is going to give us an update on his Pepito robot, and
we got
and Jim will follow with a update on its robot Big Orange. So
hey,
you want to?
Usually, hey Ben, there's only 4 people, which is just us.
All right, we don't get
it's
huge
okay.
showings, but
That takes one.
there's always somebody online, like
Yeah,
a dozen or so online.
What to do?
but
in fact, there was
this
a lady.
is
Did you see that?
mainly
I sent her.
I sent her too. I couldn't tell. I CC'd you guys, but
yeah.
she's
so,
supposed to be on here.
Is there any
But I
bug
just
that
clicked
caused it to
in.
overwork here? No.
but
There's no bug that caused
So
it
you
to
saw the
overwork here,
Andor
right?
series.
it's also, I mean,
Yes.
it's also
Wasn't
mainly
that the
for
best ever?
people who can make it.
It was
and can watch
okay,
on
you know,
later.
Oh, we're recording.
Yes, yes.
No, it's fine.
It was a
I
good
thought there might be
story,
a
I
technical
just-
issue.
I want to see
Yeah,
more
because of that,
boards and things.
that
Well, it's hard
Kim,
to, it's hard to
lady,
pitch
she
content.
said she wanted to
It's
show
like,
it.
But the droid.
She sent me.
oh, the droids, yeah, I got you. Yeah, it was more of the human element.
Okay, I think so. Anyways,
And which is
Yeah,
true,
okay,
because
we can
he's
get
from
in
Rogue
anybody,
One,
Yeah.
Alan, you want to?
and he dies in Rogue One.
You're up, Alan.
And at the end, you know, though it's.
Yeah.
All
so
right,
this is the
good
prequel
morning,
to-
everyone.
it's actually
Let me
the
go
prequel.
ahead and share my screen really quick. And let me bring you up to speed on Pepito. So a lot's happened. I purchased a resin printer. I've been redesigning the entire parts in the body around the capabilities of a resin printer. What we've got here is pretty much the final design. I'm just making a couple of more tweaks to the servo case, and then I'll carry that forward to all the components. And it's time to think about how I'm going to control all the servos. Because my nickname is Overkill, the final design has 24 servos, 6 in each arm and 6 in each leg, because why not? In a symmetric design with a 3 degree of freedom hip and a 3 degree of freedom shoulder, which means that I've got 24 sets of wires with 24 connectors, and they all have to go somewhere. So in earlier iterations, there was a backpack. This time around, I couldn't help but notice that there was some space between the shoulder blades. So let me go ahead and get them back in neutral position. And so it got me thinking about how could I set up a microcontroller with 24 things that would fit between the shoulder blades and still give relatively full freedom of movement. I was looking at the Raspberry Pi Pico, the board, and the board was just 2 IOs short of everything that I needed. And so what I decided to move forward with is a board called the TC 4.1. These boards are awesome. They have the same availability issues as everything else on the market right now, but they're super powerful. About $30 for the board. It's a 600 megahertz Cortex M0 processor with a micro SD slot. There's capability of adding an Ethernet if you wanted, external RAM. The things are just a beast. In terms of what I need, it's actually overkill, but it'll suit my needs nicely, and it fits between the shoulder blades. The other thing was I need some buck-down converters. The thing's going to be powered off of 2 LiPo cells, 7.4 volts, which is going to fry everything. And because there's 24 servos, I need 3 buck-down converters. I need 1 buck-down to supply reliable power to the microcontroller, and then I decided on one buck-down for the left and 1 for the right. The buck-downs typically claim to be able to support 2 to 3 amps. That's what they say. I actually budget for less than that because advertisements. And the buck-down converter that I was using for Todd the Quads were these guys. They're super small, 17 by 22, super awesome, but they're too big. They don't fit behind the shoulder blade. So I kept surfing through Amazon, and I found these guys. Hold on, one of these have a, there we go. Now we're talking 11 by 20.5. Exactly 3 of them fit in the same footprint for the TNC 4.1. All right, so now we've got power. And then since then, last night, I saw that there was an even slightly smaller one.
You gotta adjust the potentiometer there to the little resistor?
Yeah, so that's a good question. On this version of it, you've got options. You can set it manually through the use of potentiometer, but what I'm doing is I'm gonna cut that trace and then just solder bridge off for a straight 5 volts.
Oh, that's cool. I didn't know you had the option.
Yeah.
Okay.
Yeah, and for, there's a slightly smaller one that I'm not currently using. This might also be an option for some projects. Unfortunately, this one doesn't have the fixed voltages, so you would be using the potentiometer to manually set and then, epoxy or hot glue the pot down to get the right voltage. So we've got a microcontroller, we've got buck-down converters. Let's figure out, the next stop was to figure out how to get everything to fit, or if everything would fit.
What's your battery initial voltage or your source battery voltage? Something high, I
A
guess.
pair of 18650s with
Oh.
7.4 volt.
So 12, 14.
Sorry, 3.5 volts each, so.
Yeah,
7.4,
7.
Yeah.
I see. So you brought down it.
Yeah, I found these great, they're these Phoenix cells. They're in the 18650 format. They have a built-in BMS. So in theory,
in the
yeah, I
battery,
can just
right?
plug it into a battery holster and I'm good to go.
Yeah, those
Are they that big size?
They have that little extra at the top, right? Where the.
Yeah, so they
BMS is like-
take out a little bit of battery
take
capacity for the circuit board.
Right, so it's, right, obviously same size as. the
Yeah,
traditional.
yeah.
And you pay a little bit extra for those, I think, or.
Yes.
From China, it doesn't matter.
Yeah, but I don't have to worry about BMS at that point, so like one less board.
Oh, actually, it's a savings, or it's equal.
Yeah. Yeah, so the next step was to see if I could get everything to fit. So I went to GrabCAD. I downloaded a model of the TNC 4.1. That's the first place I always check before.
GrabCAD.
GrabCAD.com. Yeah, they've got people post models of all kinds of stuff. And so using that, we'll pop in a set of headers, 20 pins on each side. And then we'll set up a buck-down carrier board on the back with some cutouts, and then we will populate it with our downloaded buck-down converter, which was conveniently enough. Also there, so I'm mounting them through hole. So the board's on the inside, and then their guts can hang out on the other side with no interference. So far so good. This looks like it's going to fit. And this is literally how I figured out that I could do this. I brought everything into Fusion because I'm a Fusion head. And then we'll take another set of donor plastic header pieces and slip them on top for spacing. And then we'll populate the servo backplane on the other side. And then we'll cut off actually in the model, there's no excess to cut off when you do this live. I'll pass this around in a second. And then each one of these servos is being wired with a 4-pin connector with a pico blade of 1.25 millimeter centers. And it turns out if you only violate a couple of design rules, like getting too close to the solder pad, there's enough room for 24 connectors. Each side for an I2C or an SPI ADC, 12-channel ADC converter, because I don't have enough pins for 24 servo pins and 24 ADC pins even on the 4.1. I may not have enough space, and I may not have the interest in doing this again, so we'll have to see. And everything fits into this stick of gum, package of gum type package. And so starting here, realizing it was possible, I then went and designed the circuit boards. And actually, I got them back on Thursday. And they look beautiful. So what sorry, I'm looking at the wrong mouse, so let me go move this out of the way. So what I wanted to share with you guys today was the design process to move from protoboard, or breadboard, to getting a design into an EDA or a circuit board designing tool, and then upload those and get a quote and have them ordered from one of several circuit board manufacturers. This is a tool that's been available for more than a decade. When I first started looking into this, like a decade or more ago, 2-layer boards were the norm and 4-layer boards were expensive but possible. Ordering a set of 5 of each of these boards with DHL 3-day shipping was $35. So I ordered a first set without the ADC because I needed to get started, and then if I have interest, I'll design a second version that has the ADC converter and then pay them to manufacture it. And in theory, everything will just work. So I also brought in a kind of like a fitment test where I kind of just plopped everything together. And okay, video's not going to work so well. So let's do. I didn't do share for video.
It was great on mine.
Oh, okay.
Yeah.
So yeah, I'll go and I'll pass this around. And so far, again, everything looks like it's going to work. Yeah, it's janky, but it fits very well behind the shoulder blades. And once I test out the boards and the solder, 0.5 millimeter solder and solder flux and solder paste comes in. Oh yeah, here. No, that's okay. I just can't see.
And did you?
I don't know, roll my chair. Oh, I did it.
Yeah.
So this has got the teensy and your boards in
Yep,
the
and
same.
the 3 shutdown converters and both of the boards.
Oh.
And
Did you have to
all
do?
24.
Did you do some surface mount soldering? Then?
That one doesn't require surface mount, but I'm going to use paste and a hot air gun.
Oh, okay.
But yeah, it turned out it's kind of a nightmare.
Yeah.
Because while I designed everything on the screen and everything fits on the screen, and everything looks fantastic. In real life, it's a lot smaller. So, like I said, I'm going to do this once, and I'm hoping I'll have time to do it again.
Alan, what is that in the middle of the board? It looks like a surface mount something.
Yeah, it's a surface mount.
Yeah, it's a placeholder for 2 ADC chips because I want to be able to pull the rough position back.
Okay.
And there's not enough ADC lines
So
on a TC to do that.
I'm unpopulated right now.
Unpopulated
Yeah,
right
you
now.
can see it
Yeah,
right
yeah.
here.
Yeah.
So yeah, I got a bucket of stuff. We'll pass around that. And so I'm coming at this as a beginner. For anyone who is electrical engineer or does circuit board design, if you have feedback, let me know. Jump out. But the ability to take your design to the next level and to design and it's at the point where there's no reason not to if it's something that will help out your project. So my tool of choice is called KiCad. It's free and it's open source. I would say the standard bearers for low-cost hobbyist circuit design, Eagle used to be the place to go. They had a free limited version that a lot of people cut their teeth on. But when Autodesk bought them and temporarily changed the licensing, it turned a lot of people off. The things we're going to talk about today, the techniques, the approaches, will apply to any circuit design software. I just happen to have settled on KiCad. Some other ones are, you'll see in some manufacturing houses, they'll recommend Easy EDA. It behaves very similarly to KiCad. They have an online version and a downloadable version. It's the same approach, the same general idea. And one of the tools that the pros use that I've looked at but I can't afford because I don't do this all the time is Altium. If you have the money or the need or are doing things at the pro level, this is the tool to have. And I always forget how much it costs. Oh, 12 grand.
That's expensive.
So these are the main ones out here, yeah.
This is expensive.
And so let me walk you through how I designed the boards. Now, the first way I'm going to show you is the way KiCad prefers to be used. And Alan, they need a link to the Zoom meeting today for the club. I don't know. Sorry, give me 1 second.
There's a problem.
Thomas is online. So.
Yeah.
Oh, he is?
Yeah, he's on.
Maybe there's a bad link somewhere.
Would you mind forwarding the Zoom link to Tim?
Zoom works, guys.
no,
I'm
that's-
here.
He didn't get it.
Okay.
He didn't get it.
Looks like I'm the only one though.
And
Someone just,
yes, sir.
someone just tried to say something, but I don't think we hear him.
No, it's Thomas.
Oh, I don't know.
Let's turn the volume back up.
Your volume's fine, Alan. Everything works.
Oh, good, thank you. In the workflow for designing a circuit board, everything starts with a schematic. So this is where you end up. The way KiCad prefers to work, and I'm going to show you this way first, and then I'll show you the cheater way for the buck down board because it was so much simpler. Is it starts with a schematic. And where we end up, and it took me longer than an hour to make this, so we're not going to end up here exactly when the talk is through. You draw a schematic that tells the program how everything is supposed to fit together. Now, the final schematic for the servo board looks like this. As you can see, there's a lot of repetition, a lot of copying and pasting. That's totally okay. You can ignore the ADCs. I'm not even planning on using that one in the final. So we have a 20 row by 20 row header that we're using to represent the teensy, and then each one of these 4-pin connectors represents a servo header, a servo connector. So let's get into it and walk through some of the.
So you said you're only going to be using it 3 pins on it when you were originally going to use 4?
Yeah, I'm actually going to wire it for 4 because I would like to use position, but
Oh, God.
we'll see if I still have the patience for that.
You have the option for it.
Yeah. All right, so we'll start a new project. So file, new project, it asks you for a location and a name. I'm calling this one Club Servo Packad. It generates 2 files for you, a schematic and a PCB. In the preferred workflow, there's no point of going into PCB until you have the schematic, and I'll show you why in a couple of minutes. So let's go ahead and open this up. All right, sorry, go ahead and minimize this window over here. And you're presented with a blank schematic diagram. Now, when you download and install KiCad, it has tens of thousands of components built into the library. In addition, KiCad is supported both at the hobbyist level as well as commercial level by a large number of people. More often than not, you can go to the manufacturer's website and download the definition of a component that they sell, the footprint, the schematic option, even the 3D model sometimes. And if you were to do that, you would be able to find the schematic for TNT 4.1. I'm not, this time I did not to do that. I opted to model the 2 pin headers, the connectors instead. So I'm going to go over here where it says to add symbol, click on that. And I'm looking for a connector, so I'll type in connector. And let's go ahead and scroll down, scroll. And I see right here, I have a generic 20-pin male connector. Let's go ahead and double click on that to bring it into the schematic. And let's dig in this a little bit so we can see it. And it brings in a couple of things, 20 pins, there's a beginning and the end. And so I need another copy of this for the other side. So I'm going to select this, and then using keyboard shortcuts, Control-C, Control-V. And we've got the other side of our teensy. Again, I didn't bring in a teensy model, I'm just going to bring in the connector. And on this side, I kind of want them to face outside different directions. So let me go ahead and select this guy again. And let's flip it, mirror it left to right. And I'm going to click on Move M to move it. And we'll move this back over here. And so there's two sides. There's the side that you connect to and the side that you don't. The circles are the ones that you connect to. And so for now, I'm just going to leave that right there. So we have a representation of all of it. Now, we also need a representation schematic for the servo headers. So I'm going to click anywhere and type in connector again, because I can never remember where they are. And I want to go back to those generic. Now, most of you remember servos normally have a 3-pin connector, power, ground, and pulse, right? Because I'm a glutton for punishment, I'm actually going to wire in a 4th wire to bring the potentiometer lead out to give me a crude measurement of position. It's not super accurate, but it's better than nothing. And since, what's the word, sadist or masochist? The one you do to yourself.
Masochist.
Masochist, okay. I'm going to solder in that 4th pin, and I've already purchased the headers and everything. So I'm just going to grab a generic 4 header right here. And I'm going to set this off to one side. Now, the each one of these pins has a different function. The first pin is going to be for power. And so I'm going to click over here for power port. And I'm going to open up the power dropdown. And these are going to be powered through 5 volt. So I'm just going to grab a 5 volt. So it's still in my hand. I'm going to flip it to the right, like so, and connect it there. So I've said that for this connector, pin 1 is a 5 volt. Let's go back over here and find a ground. It's quick and dirty. We'll flip this around a couple of times. And so we've said that pin 2 is ground. Now, in my wiring diagram, pin 3 is the servo pin, the pulse pin. And when you just get started, your instinct is to set up all the components in the schematic the way they'll be on the board, and then like trying to draw direct wires connecting them. And for some circuits, you can do that when you're doing passives, when you're doing filtering and stuff. Sometimes it's better just to wire them in directly. Now, wiring all of these indirectly would be a nightmare because I've got 24 of these connectors. Each one of them has a servo signal pin, and it just would be a rat's nest. Good word to remember. We're going to get back to that in a second. So instead of doing it that way, I'm going to set up a label. And for this label, there's 2 ways of doing it. I'm going to call this servo 00 for now. And I'm going to stick that there. So what I'm saying is that there is somewhere else on the circuit board, there is another label, not a bus, but a label that connects to that. And then try to read it later. And so on the other side, there's going to be a corresponding S00. that it connects to. Now, why are we taking the time to draw out the schematic and do everything? Well, first off, so you can remember what goes where, right? Secondly, I'm going to show you this when we move over to the circuit board design, because this is all math, connecting points, meeting criteria, and da-da-da. When you get to the circuit board part where you have your components and you lay them on the board and you figure out where to position them and where to orient them and how many planes you have for signaling to get everything connected, that's when science and things become really fun. And the circuit board designer will obey all your circuit that you've designed. So if you say that this signal over here is supposed to connect to this signal over here, the circuit board portion will represent that with a line, a rat's nest, and then that rat's nest line will be visible until you connect it. I'm going to show you how all that works in just a second. But for now, we have this one connector. You go ahead and go back to selection mode. And let's call this, J is, for junction or whatever. Like servo 00 or whatever, right? I'm not going to label, but you would do something similar, right? So on my second version, if I ever have the energy to do it, I would set up a global label for that and then wire up the rest of the ABC so it makes sense. So here I have an example of one of my servo connectors. I've got 5-volt ground and a signal line. Now I could draw each of them individually from scratch, but if you think I'm doing that, you have no idea how lazy I am. So I'm going to Control C and Control V. Oh, sorry. Oh, that's okay.
Sometimes the Maxicism wins out, sometimes the laziness.
Yeah, it depends. Sometimes I'm not sure why I do some of the things that I do. No, you're perfect, thank you. So we'll do like 6, let's say. Now we can't stop there, but that's a good starting point. So we have 6 connectors. We have the 2 sides of the teensy, and I'm going to go ahead and save. Always a good idea to save every once in a while. And this is not complete by any stretch of the imagination, but I'm going to skip a couple of steps and then we're going to go back and show you why they're important, because why do things in a straight line when you can skip around? The next step is we have a schematic in, and like this barely passes for a schematic, but it's a good starting point, is we have to assign footprints to each of the components. So when you think back to what a completed circuit board looks like, the schematic tells you what it does and how it's connected, and the footprint describes how it's going to appear on the board. So for that 20-pin header, when you assign the correct footprint, it gives you a hole, and then it gives you a copper circle that surrounds it, right? And then it gives you a keep out area, and it describes how the solder mask behaves around it. This is what's called a footprint. So before we can start populating our circuit board, we have to assign each of, wrong window. Too many windows. We have to assign each of our components a footprint. So there's a couple more fun little buttons here I'm going to press. It's going to, sorry, I'm going to drag the bar down here. So there's a button, and it'll make a best effort to fill in. You see all those question marks? It's like, I don't know which number of component this is. Well, you can have it number it on your own by clicking here. I'm going to do it just so you can see it happen once. And so now 0, 1, it figured out that the servo prefix 0, 0, 1, 2, 3, 4, 5, J1 and J through, it just filled in the blanks and gives each of your components a number. So for a bill of materials or something more fancy, you can use that. The fun part is where you go and you assign the footprint. So we'll click on the footprint assignment tool. It's a lot faster on my desktop at home. Oh, even better.
Are those pins 3s that say S00, are they supposed to follow the servo number 2, like S04, S05?
Yes.
Yeah, okay, yeah. I'm just,
Yeah.
Yeah, it sounds like
That's an elevator.
All right, so I need and sometimes it'll without getting into the search, sometimes it'll recommend a same default. It is not doing that here. So I'm gonna take off this filter footprint list by library to get all of them. And then I'm gonna do a search for connect. Oh. It's a little bit slow, so if you type too fast, it puts the letters in the wrong spot.
Right, because it's doing a search. That's a slight UI error there.
Mhm.
You should wait a couple milliseconds.
All right, so let's scroll down, scroll. And I can't remember exactly what they're called. I know that they're a connector. Oh, good Lord. Okay, let's do 1 by 20. Oh, no, not one. 2, 3. 1 by 20. There we go. So let me move this over so you can see it more. Right, with any kind of search, you start with what you know. Connector wasn't very specific, but I know it's a 1 row by 20 pins. And here we have connector pin header, 1 by 20. The spacing in most stuff that's not surface mount is 2.54 millimeters. I'll rant about that in a few minutes. And so let's go ahead and select 1 by 20, 2.54 vertical.
that's 1/10 of an inch, huh?
Yeah.
Yep. Yep. Okay, so we've defined a footprint. So it's a 20-pin connector for the 2 sides of the teensy. So the connectors that I'm using are actually JST MX. They're a 4-pin connector with a 1.5 millimeter spacing. Now, while that isn't available as a default in it, there is something similar. There's a much more expensive version of that called a Pico Blade by Molex. The connectors are totally different, but their pins have 1.5 millimeter spacing. So we're going to use that. So let's look through here. Pico Blade 1.25 vertical by 4. I think that's it. Let's do that one. And then we'll assign that to all of those. Okay. All right. And so what we've done is we have a circuit board. I made a whole bunch of errors on it. That was a good catch. We've assigned footprints. We'll go and click on save. And then let's move over to Open PCB and Board Editor. All right, so now we're in the PCB editor, but we haven't brought anything in yet. I'm going to zoom in a little bit, and then one of these options is Update PCB with changes made to schematic. We're going to click on that, and it kind of tells you everything it's going to do. It's going to add in a whole bunch of stuff. And so it brings in all of the footprints from the schematic, and it's just stacked, right? We have a couple of lines here. The lines in the PCB editor that explain how things are supposed to be connected are called a rat's nest. And they're just a reminder that some things are not connected. And so what we need to do is to start arranging this. Now, a quick minute rant on measurement units. In engineering, including circuit board manufacture and design, it became a thing before the civilized world moved over to metric. So as a result, circuit board measurement requirements, etc., are expressed in terms of inches. So you have inches. You have a confusing unit of measurement called a mil, which is a thousandth of an inch. I prefer to call them thous to differentiate between thousandths of an inch and a millimeter. So much like England and Slovakia and some other third world country, we express things in inches. So when you see things like, oh, this header has pins on 2.54 centers, they're not being silly or crafty about it. That is the inch equivalent, because in English units, that's 0.1 inches.
Imperial units. England is metric. So,
English versus metric.
Imperial.
Imperial.
Yeah.
it's us in like Moldova or some little island country. We're the holdouts.
Hold on.
England is partially metric. They do use some imperial.
Oh, U.S., Liberia, and Myanmar. So.
Yeah, we're in good company.
Top country.
USA.
They're imperial units.
I think they use it in clothing.
Oh, wow. So in order to get this spacing right, I'm going to start out by keeping the grid at 2.54 millimeters, which also enforces your movement. So I'm going to select one pin here and hit M for move. And you can see that this is snapping around to 2.54.1 inch centers, which is a great way to start. So I'm going to move the first one there. I happen to remember that the TC is 7 units wide. So I'm going to grab this, hit move. 1, 2, 3, 4, 5, 6, 7.
Nice.
Oh, so it's exactly, it is in the same.
Yeah. So the grid
Yeah,
is
it's
in
in DIPS compatible dimensions.
Yeah.
Let's move this out of the way. Now you can see we've got these lines that are all connected, and this is because, getting back over to the schematic,
All the 5 volts are connected.
because I was lazy, all of the signal tags are labeled as 0.
Yeah.
So the schematic, the board editor is helpfully reminding me that these are all not connected yet. So we're going to get back to that in just a second. Oh, no, I keep clicking on the fun picture instead of the schematic. All right, so there we go. All right, so in the servo board, we've got the 2 connectors, and now each of these needs to kind of fit inside. Now, I can't leave it at 2.54 spacing because, first off, these are 1.5. That's not going to really work. So I'm going to change the grid to, let's say 1/10 that. So 100ths of an inch. We'll zoom in. I'm just using my mouse wheel to zoom in. And then let's see, that's servo 1, 2, 3. Let's say 1, 2, 3, 4, 5, 6. 1, 2, 3. Let's move that right there for a second. Let's grab servo 1. I'm just clicking on any pad and hitting M for move. Pad, hitting M for move. So I'll have to be a little bit more creative when placing them, but just for now. Oh, this was supposed to be servo 0 because we're 0 indexed. Darn it. Little shifting around, so I click on a pad, curse under my breath a little bit, and then let's get these roughly arranged. 0, 1. Here, we'll dig in this a little bit more after I get things arranged. 3, 2, 4, All right, so this is a mess, but they're roughly in the right position, and we know the 220 pin headers are in the right position. Let's see if we can clean this up a little bit. Now, first off, all of these labels, I don't want to be visible because that's just a mess and it doesn't work in my layout. So I'm going to double click on everything that I don't want to see, because if you see it on the schematic, it's going to be rendered when you print your circuit boards. Let's say I don't want that visible. That visible. I don't want that visible. Now I'm doing this the hard way. There's a slightly more complicated way that involves modifying the template. And then you can apply that to all 12. But for now, double click, unclick, visible. And this is the boring stuff. I'm gonna stop after this one. Maybe one more. Sorry, my OCD's kicking in. Okay. All right. So we've got things roughly where they are. I would probably make the grid even finer, and then we could position these even better.
You can like align to use an align tool and that sort of thing, right?
Yeah. There's a couple of different
Or
tools.
snap, you can use this rather than put them each, using snap. Obviously, snap to grid is fine too, right?
Yeah, that's why I'm choosing different grid sizes. So I wanted the headers for the teensy to be exactly at 2.54. And then these can be arranged and
So right now you're working on this.
yeah.
Cool.
Yeah, so we'll arrange them roughly. I would go back in and remove a lot of the labeling, right?
So if you didn't remove that, they would have actually written on here,
Yeah.
servo, blah, 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 and all
Yeah.
of those have been squished.
Yeah.
Yeah, it's in the silk screen layer that you can put labels.
Yep.
That's cool.
So under board setup, there's a couple things you want to check out. Oh, no, that's not that. So by default, KiCad believes you have 2 layers because 4 layers are so cheap, and with the ADC, I'm going to need some extra layers. We're going to change this to 4 copper layers. It goes up to, wow.
What does that mean exactly?
Generally
layer
on
on
a
here?
circuit board, yep, so there's
Okay.
2 layers in the middle that you can't see.
Oh, inside here?
Mm-hmm.
So you're gonna use,
Oh,
you need 4.
okay.
Yeah. All right, so we've told the board that we have 4 layers, and then it's a matter of,
In a perfect world, do you not overlap the purple border? Is
in a
that-
perfect world, you do not. That's called a keep away or a keep out zone.
Yeah, okay.
And so we're violating a couple of design rules.
Yeah, you mentioned that in the beginning.
And getting back to the model here for a second. So, this would never fly for reals. And as a result, because there's a hole through here, right, and some copper, is that I have to place the servo headers first and solder those in, and then solder in the header and hope I don't melt the connector. So there's still a couple of things that could go wrong.
Yeah.
It's right on the edge between brilliance and insanity, probably closer to stupidity.
Tight
But
collar.
it works. All right, so we've got your components loosely placed. Now, in a real circuit design, there are some things that have to be in a certain spot. This would be like the headers, and others like your passives, your ICs, and you want to position them such that the rat's nest that you see of the potential lines that needs to be connected are less rat's nesty than before. And so there's a point where you position things like, oh, it's as good as it's going to get. And that's when you get to work on laying down the signal traces.
Alan,
Yeah,
do they have something like a micro spot weld?
I don't know what that is.
Well, in other words, they have these small spot welders, for batteries and that kind of stuff. Well, the size that you're using, you would do a micro spot weld
I'm not sure if
rather
they
than
do.
slump a bunch of solder around.
Yeah, in this case, I'm going to use solder paste out of a syringe
I see.
and hot air gun to save
Okay,
me
yeah.
from the hell that is 150 individually soldered.
So you're gonna solder a bunch of stuff at once with a hot air gun?
Mhm.
Like 400 degrees, or how hot is your hot air gun?
Whatever it takes. I'm not sure. I haven't looked up the.
Usually, for soldering something like that, is somewhere like around 700 degrees.
700 degrees.
That's like a reflow oven you can also use, right?
Yeah.
Yeah.
Oh yeah, that would also work.
So it's a special gun just for soldering?
So it's not like,
I mean, you can buy different sizes and stuff, but for something like this, the nozzle may be about the size of the finger. It's.
Okay.
Oh, it's much smaller. I have a
That's
big
not-
one for shrinking
I have a
monocoque
standard
Oh, yeah,
one, that wouldn't.
over an airplane wing, you
We
know?
actually used one yesterday of that size for a little board and anywhere.
Oh, it did work?
Yeah.
Oh, for the big one, for the standard,
It was, we borrowed one from, I believe it was the metal shop. It was like, the stuff they use. It's about the size of a hairdryer.
Yeah,
That's how big mine is.
That's
Yeah.
what I had.
And we surface mounted
Really?
a USB-C port on this little tiny board that was like, really microscopic anywhere.
You put it in like mine has like two.
It only,
You're saying you're
it has,
afraid you're
it has a
gonna
trigger,
want these.
it has a trigger that has like 3 trigger points, like medium,
Yeah,
low, medium, and high. So, I mean.
so you just.
While we're talking, he's cleaning up he's waiting patiently as.
My
Sorry,
OCD.
sorry.
Yeah, no, you're good. You're good. And
Use it
so,
on high.
yeah. So initially, I'm like, I'm gonna have to solder 400 connections with a magnifying glass, and then Ben's like, why don't we just use solder paste, bro? So I
Wow.
ordered some
But
solder
You
paste
still have the syringe to 400.
and the syringe, and I ordered 0.5 millimeter rosin core solder, and I ordered 1.5 millimeter desoldering braid. Like I ordered like,
So the
40
solder
bucks
paste,
and
you heat it and it melts.
it just.
It comes in syringes.
And the syringe, you ordered on Amazon or something, or I've never even heard of that, but I get the concept. It's just I've
And you
never
still
heard.
have to like, administer the.
Yeah. So there's still.
So you have your magnifying glass and you're syringing the dots and.
Yep. And what's nice between the solder mask and the exposed copper, when it melts, it tends to cool
Yeah.
outside of the solder mask.
Yeah.
So,
Yeah.
and then for the parts that solder bridge, you go in and you clean them up manually. So.
Okay, that's
So
awesome.
you're
I've never
getting
even heard
the
of that.
mask made too. Like I didn't have a mask made. In this case, you're getting the solder mask
Yeah,
made from PCB.
Mhm.
Yeah.
Yeah. So now that the parts are laid out, and I apologize, it went a little bit long. You get to draw in the connections. So you select the layer that you want your trace, your connection to be on. Now I said it's a 4-layer board. So by convention, it's F, N1, N2, and then B. F is for the front and B is for the back. And so if I wanted to draw a solder trace on the top layer, I would select that. So the arrow's on it. And then one of these little guys is a root or a track. You select that. And then you try to connect it. You'll notice it snaps to the center of each connection point. And let's say I wanted the servo signal for this to connect over to one of these pins. So you click on it. And then it's red because I'm on the top layer. You can see just like up here. And then you draw that trace where you want it to go in order to connect.
So you're choosing the layer, the program doesn't choose it
Yes.
for you.
Yeah. And then you'll notice like the only thing that I can connect to are the other signal pins. So I skipped a step. I can't connect to where I want to. But in this case, I am wiring the servo pins. I don't know where I'm going to wire them until I have the placement. And so I'm looking and I'm like, oh, this pin 5, this would be a good place to connect to. But I can't right now. So I'm going to hit escape and go back to the schematic. And so pin 5
Now,
is
was
where I
that
wanna connect
J2?
to, right? So I'm going to grab this guy, Control C for copy, Control V for paste, and then flip it around.
I thought it was J2. Maybe not.
Oh, shoot. Let me look back over there. You have better eyes than I do. So servo 4. All right. Yep. servo 4. So let's go over here and let's call this one, you can either label it based on the teensy pin or label it based on the servo. I'm gonna label it based on the teensy pin. By the servo, so S04. And we'll up this one, call it S04, because we don't know where they're gonna connect until we do it. We'll go ahead and hit save. Move back over to the board. Pull in the updated schematic. It'll tell you the changes that it's making. And then update PCB. Oh, I have them backwards. Do you see that? I've got the J1 over here.
That's
J1
what I
over
was
there.
saying, the J2
Yep.
and J1.
All right, so let's switch back over to 2.54. Grab and move. Grab and move. Grab
Oh,
and
that's
move.
easy,
We'll
you
fix that.
swapped them. Wow.
All right. And so this is what I did for all 24 of them, because I didn't know where I was going to connect them until I had things laid out. And now that we've updated the schematic, we can click on line, click on the signal pin that I want to connect, and connect that over. And now we have a trace that connects pin 5 on the header over to servo 4 drive pin on the top layer.
I noticed there was a white line already connecting those two, because they're probably both less labeled SO4.
So that's your rat's nest, and because I was sloppy on the schematic, we'll get back over there. Now we can go back over here and call, this one SO3, because this is servo 3, SO1, SO1. So we'll clean these up, and then as we go through the schematic, we'll bounce back and forth, which is a little bit of extra work, but at the end of that exercise, I now have a map in 2 different locations of what's connected to what. So when I create my servo object in Arduino, I can say servo connect, and then look up what pin this is on the teensy pin out, and we're good to go. All right, so as I mentioned, the whole circuit probably took me more than 40 minutes to do the whole thing. So let's go back to a circuit that's already done. We'll go ahead and we'll save that out.
Yeah, but when you're doing this, is there's like some convention you use, like I'm gonna put my signals on this layer, my grounds on this layer, and you have something that helps you?
There are a couple pieces of wisdom. In some types of design, they'll put their signal, their power and ground on the inner layers, and then they'll put those signal layers on the outside to make it easier to troubleshoot. I've also seen designs where they use power and ground on the outside and use signals in the middle. It depends on how many ounces of copper and how much power you're running. In JLC PCB, the one that I went with because it was the cheapest, the inner layers by default are 1/2 ounce copper, and so are designed for signal. And because I'm running a lot more power through the board than the raw copper would allow, in my case, I'm running power and ground traces off of the back. And I've removed the solder mask from them so that I can solder bridge to give me about 8 times the width than it would over copper alone.
Which goes outside, just so you can thicken the copper up.
Yeah, exactly, because each trace could carry upwards of an amp, 1.5 amps, which is just more than you can ask even a 1 ounce copper on the inner layers. And JLC PCB supports heavier copper in the middle and at the end, but you're going to pay more. So there's all kinds of different considerations. What's nice about this solution, putting the power and ground lines on the back, that actually gives me 3 signal layers. I only needed 1 layer to connect all of the servo lines to each of the pins. But with 3 signal layers to choose from, that gives me more than enough room to run out traces for the analog to digital converter for the front and the back. And that's everything that I've learned about which planes to use for which ones.
That's good advice.
So let's go ahead and we'll go back to the finished servo board. And in the short time that we have left, let's walk through what it looks like to order a board. So I'm going to open up the PCB right now. And I'm going to set up a cubbyhole for where I want those files to go. So the files that the manufacturers use to produce a circuit board is called Gerber files. It describes a format and a convention. I just want a place to stick them so I'll know where they're at. So OCD Allen under projects has Pepito and then a spine subfolder and then a servo board subfolder and then a Gerber's folder underneath that. I'm going to erase everything in there. And so here's where I want to put all those files, just because that's where I like to stick them. So we'll go back over to the PCB. We'll go to File and Fabrication Output, Gerber's. And there's a couple things you want to click. First off, you want to tell it where you want to put the files. So that's going to be under Spine Servo Board. And then Gerber's. I did not want to use a relative path. That sounds scary. So we'll generate the plot files first. And then it does a whole bunch of stuff. And then I also want to generate the drill files. I generate everything, even though they may not be able to use it. Most importantly, here's the drill file and the mint file, and then hit close. So there is a lot of stuff in here that probably can do to customize. I'm using the standard design rules. There's nothing special about my board. I'm generating the all the Gerbers, and then you go back over to where you stuck them, hit all, and then put them in a zip file. It's an interesting name for it. We'll call this Servo Board Club. And let's open it up to see if there's everything in there. Perfect. All right. So now you've got everything packaged up. Where do we want to get these things printed? Now, there are a couple of manufacturers that I'm familiar with. Now, back in the day, and if you're concerned about IP and want things done in the US, one of the lower cost options was a place called Oshpark. They made a name for themselves by only using purple PCBs, but they're great. I think they're in Northern California or in Washington. They're close. They're not the cheapest, but if you have concerns about IP or keeping your designs in the US, they're a great option for prototype manufacture. I've used them several times in the past. The next one is, I'm sure you've seen advertisements for PCB Wave. They're hitting the YouTubes and the algorithm really hard right now, actually for a while. They've got a whole bunch of great options, and they're not a bad company. They're also based out of China, like the JLC PCB. But I actually went with JLC PCB. Not because I have brand loyalty, but when I uploaded my Gerbers to all 3 sites, this one was the cheapest. I have no concerns about intellectual property. This is just a silly doodle. When you go and sign in, which I'll make this super quick. That's not great. Let's try that again. I'll go ahead and I'll sign in just as Google because it's easier than creating an account. And let's go ahead and upload that zip file. So we'll click on upload. It says add a Gerber file, but it's actually a zip file with a bunch of stuff in it. Go back to documents, projects, Pepito, spine, servo board, Gerbers. And we'll grab that. There's a benefit to excessive organization. You upload all your files, and here, let's dig in this a little bit so you can see it. I didn't like something, but all right, so I see the front, I see the back. We can go into a Gerber viewer to just make sure it, for 2 things, to make sure it understood the design, and I haven't had a problem with that yet. Done successfully, thank you. And you can go through and look to see, to make sure all of your design features are represented in all views. Top and bottom are probably the coolest, or layers. The second reason you want to do this is if this is your last chance to make sure you didn't forget something when you order the file. Because once you set it to manufacturer, you're locked in. Now, funny story, this servo board was uploaded as a prototype, so I wanted to get it quick and quick and dirty. And so I didn't populate the ADC and all those signal lines. As a result, I didn't put anything into interlayer 1. Interlayer 1 was blank. That's the way I intended it. I just want to get this out, and at some point in the future, I may finish the job. Now, they have their own design rules to make sure that your design is valid, doesn't exceed the capabilities of the machine, and also, as it turns out, if they have any blank layers. So they actually held my job. And they're like, hey, bud, just so you know, your layer 1 doesn't have anything on it. Was that intentional? And after I said yes a couple times, they're like, okay, if you insist. And then it went to manufacture. The whole process with DHL for 2 to 3 day shipping, it was a 1 week turnaround, including that 1 day delay, which I absolutely loved. That is just the most amazing thing ever. Also, when you submit your job, it'll show you where in the 20-step process it is, from imaging the inner layers to laminating the outer layers to fabrication, the circuit thing. You can actually follow it along virtually, and it was fun.
Total cost with shipping was $35.
Yes, so your first order, you get $10 off shipping. Okay. So it would have been
45.
Yeah.
And that's from Shanghai or somewhere, or?
Yeah, everything's in China.
Yeah, that's pretty good. And then if the 5 work, then you can do 100 or something.
Oh yeah, if you were doing a product, yeah. So looking at this one board, so just stamp box.
The shipping is the bulk of the price.
Probably. Yeah.
Well, if I would have waited. Could have waited a few more days, shipping would have been free. I think
wow, it would have been free. Oh, no.
Yeah, and so there are a whole bunch of options. It has your design. For larger jobs, you can opt to panelize your own design, or they'll panelize it for you, meaning how they want to arrange all of your copies so they can be printed.
Now, had you clicked aerospace or medical, would it be different substrates or different specs of
yeah,
quality?
So there's and same thing for medical. There's a 4-wire Kelvin text and material.
Oh, I see. There we go.
Yeah. So different sizes. I opted for black because I thought it sounded cool. Lead-free, ENIG pre-plating. Your outer weight is 1 ounce, and this is one of the reasons that this is cheaper than PCB-WAY. PCB-WAY defaults to 1 ounce inner layers and outer layers. And if I were to select this, the pricing gets closer, but it's just signal layers for me, so 0.5 ounce, and a whole bunch of other things that I don't even know what they are, so I'm not going to touch them. So the big thing for me was the knowing what how wide the board is, and black PCB color, and then firing that off. You have a couple of different shipping options and that you can choose when you save this out to the cart and do it out. And my turnaround time was 7 days. So this presents a whole bunch of new options for you in your project. Breadboards is where I normally start. I'm sure all of us have done the proto board thing where we solder bridge the paths together, which works great. But when you're ready to take a design to the next level, there's a couple hours of a learning curve, and then it opens up a whole new world of design, including making a 24 servo carrier board that fits between the shoulder blades of a 4-inch robot.
That's very nice.
Yeah. All right, so next steps, I'm going to prove, test, and then do an assembly of the spine. It's a one-way job, so once everything is soldered in, it's not coming apart. So I'm going to take my time and do it right. And then,
what is the center? I've been meaning to ask. The center, that little center square there, that looks like some chip ground plane for a chip or something?
Yeah. So that's the solder pad for a surface mount 12-channel ADC converter.
Oh, okay, that's what that is.
Yeah.
Okay, that's the converters that you.
Yeah. So I need 2 of them, and I don't know if I have enough room anymore to mount them with all the routes. But when I'm really bored or really mad at myself, I'm going to try again.
I gotcha.
All right, so once this is assembled, I'm going to finalize the dimensions for the servo case and then design the sub-assemblies and print this out. So knock on wood, if all goes according to plan, I should have at least an arm or an arm and a leg, or if I'm super lucky, maybe the whole robot assembled for next
So
month.
that robot, he walks, is he a biped?
Mhm.
And that's going to be quite a feat in itself, you know, getting with your balancing that thing. And
I know, in spite of all of these things that I'm working on, like what I'm doing right now isn't even the hard part.
He's got all those degrees of freedom. He can make a crawler robot if it doesn't quite walk.
Right?
This is going to be awesome.
Hold on, I've got a thing. It's what are you doing? Okay, there we go.
Is that front an LCD screen? Yeah, I see. That is.
Yeah. Yeah, so this is, I bought 10 of these because reasons. And so now I finally found a use for them. I'm gonna pass this over. These are the Palm Phone.
It's a little tiny phone. What kind of phone?
The Palm Phone. It was a failed companion device released by Verizon about 3 years ago. Yeah, they're slow and their battery doesn't last long. So from a phone perspective, they're a total failure. But from a robot perspective, in that package, you have a battery with a 6-hour runtime, full USB connectivity, Wi-Fi, Bluetooth, an 8-core 1.6 gigahertz processor with 4 gigs of RAM,
Interfacing that's going to be
and
not easy
32
though.
gigabytes of flash.
Yes,
And it's all programmed in Dart and Flutter. Oh, and there's a ROS package for it.
Oh, okay. That's it.
Alan loves this tiny thing.
Oh my gosh, I want it to work so hard. And so
Camp would like that.
Yeah, it's going to be cool. There's a backpack with two 18650 Phoenix batteries with built-in BMS. So the thing should be able to run for hours, assuming the motors are strong enough to stand it up.
Where are you getting those motors from, Tim? I mean, Alan?
So I order them through AliExpress. And then after I print out the replacement cases, I pull out all the guts and I put them into my custom servo case.
So those are going to
They're
be
strong,
tiny.
resilient, back drive them. Yeah, they're. I don't know how to build this any stronger with Metal Gear servos, so I think this is as small as it gets. But after I finish this, I can apply these design principles to Todd the Quad and Teensy Spot and make them even smaller. All right, so yeah, that's all I got. Thanks, and hopefully, if all goes according to plan, I'll have some part of the robot built and maybe even moving for next month's talk. All right, thanks.
Thank you.
You answered this last time, but how are you connecting
You're
your
up, Jim.
phone to the USB, the serial, or using a Bluetooth?
Yep, USB serial over USB.
Alan, can I ask a question?
Yeah.
So that robot thing that you just showed, you bought that from somewhere?
No,
Are you
I'm
You're making it from scratch?
Yeah, I'm making it from scratch.
Okay. Cool.
Yeah, thanks.
Like your tutorial on KiCad, I'm getting into that myself.
Yeah, there's a couple hours of learning curve with the internet and YouTube. It's a quick
Oh, yeah.
study because it's a little bit different, but it opens up so many more possibilities to move your projects forward.
Well, I've got one. I got up to the point where, rat nest is all there. I'm trying to lay it out or whatever. And that's where I stopped on it for the moment. But I want to try at least finish one, see if I can do it. And it looks like that PC board company you just showed there's probably the way to go for a small quantity of this stuff to make a prototype or something.
Yeah, for sure.
Now, let me ask you another question, guys. This meeting is being recorded. Where is it stored? So if I want to go back and watch what I missed, I can.
They're all uploaded to our YouTube channel.
Here, I'll post
Okay.
the link in chat.
All right, thanks. I wish I was there, guys.
Yeah.
Yeah, me too. Why aren't you here?
A, I don't have any way to get there, and B, right now, my work I'm doing at Gunner Holt's come to a screeching halt temporarily until they get the new controller board in. So I haven't worked for them for 7 weeks now.
Oh, okay. Well, hopefully that picks up again soon.
Well, I hope so too. Right now, I'm working on project for a couple of people, and I've been messing around with these RFID stuff.
All right, well, I'll get started. Having a little problem with my VPN. So today, I wanted to mention that, back in June, I also worked on a KeyCAD project, and that was for a vintage computer, but I had a pretty good experience working with it as well, and so it definitely is. Oh, here we go. This will work. I could show briefly the end result of my work. This is kind of slow. But today, while that's loading, I've got Orange here, and so today's talk is going to be about a wake word implementation for Orange, and I'm using this. And so a wake word detector or wake word listener is a way for you to have a trained neural network model recognize just a keyword or a key phrase that will then trigger an activation callback for which then you can start capturing your full speech or the audio from for recognition for processing. So the motivation behind it, this is wake word detectors are used in all of the standard professional systems such as Amazon Echo and Google Assistant. And so when you say, hey, Alexa, and it's 3 syllables are a key factor, and that's sort of recommended for this type of neural network. It's a recurrent neural network. You'll notice they're all 3 syllables. Alexa, Amazon is an alternative. Hey Google, and so I'm using Hey Orange, which is so I've trained the micro-precise wake word. It's a recurrent neural network with the Hey Orange, and I recorded over 400 myself saying it in various accents and in various intonations, as well as getting my wife to do some, and then I also went on to the Deepfake website, or it's a Deepfake audio, and I made Bill Gates and Hillary Clinton and other celebrities say Hey Orange, and brought all those in as well. That took a little time. You can do it for free, but it's a little bit of clicking. So all those in there, plus then you get what ends up being very important is the non-wake word, which is everything else, static and all that, all sorts of noises. And so I'll get to that in a while, but that becomes a big factor because the system is an acoustic-based neural network, and it doesn't work like our human brain does. It can get set off, even though I've trained it with Hey Orange, it can get set off by the static or the sound of a cappuccino machine or a milk frother, and so we don't understand how are those related, but acoustically through this recognition of a neural network, the early processing and it actually does trigger the same neuron responses. So you have to train that those are not the response, not the correct, called the non-wake word. And so I'll get into that, but the motivation here is that my existing system and an existing system that has a speech detection or speech recognition is transcribing everything you say as using the CPU resources and then trying to figure out if there's a command in there. So instead of that, the wake word technology allows the system to remain in an idle or just listening for wake word. And on my PC, on my Edge computer here, the Celeron Latte Panda, it's a quad processor, but it's fairly low. It's a battery powered and a single board computer running Windows. That it'll take about 18% of its CPU to run the wake word detector. And the speech recognition the whole full speech recognition takes about 22 or so. It's a little bit, it's almost the same, but it's a little less. So there isn't a big savings, at least for me, in processing power. But the key aspect that I wanted this was, that I need this is because the orange will not be just listening all the time and transcribing everything said to find a command in there. And then when you do have to give it a command, you have to wait till it flushes out whatever was said prior to that. This, with a wake word, I can be talking about orange, and I'll have it running actually in a minute, where I can be talking about orange and this, that, and the other. Not only will it not find the orange in my statement like this, because the wake word is trained on hey orange with nothing around you, nothing else. So it won't get spuriously activated by when orange is in a sentence. It also won't activate and won't try to transcribe a command until I say hey orange, and then I have the little ring of lights go up like Alexa does, so that as you're saying it, you can see the lights come on and then turn orange at the end, and then you realize, okay, he's heard my hey orange, and now you give the command. So you say hey orange, and then you see the little lights, and then you say the command, go to the kitchen. And so that way, there's no waiting or processing of the previous, whatever was being said in the room up until that point. Because there's no processing of speech until the wake word is detected. Does that make sense?
Yeah.
So only the wake word is. So essentially, there's a handoff. You say, "Hey, orange," it records some audio. Then it says, "Oh, I got a detection." It hands that off to the speech recognizer, which then continues to record, and then puts all that together and then transcribes that. And so you still get a hey orange, ideally, with the full command. But you really don't necessarily need that hey orange port because you've already triggered. So this, let me see if that thing came out. See if the other computer came out. So this is just a brief go back to this. This is the one I designed in KiCad for that an audio card for my vintage Commodore PET computer. And here it was a simple enough design that I could connect everything, wires through on the schematic, and then the final board was looked like this. And this one had connectors at the edge connectors. Pretty simple through-hole solder, two-layer board design. But anyway, it's really a fun process. Definitely recommend. So you can do something fairly simple. This one was a board I just copied, and this was a copy exercise from from a schematic on paper. So I entered it all in to what you just saw there, and then designed the board from an actual picture of a board. So I didn't have to come up with a new design, but it was still, of course, I had to do all these traces. They weren't visible from a photograph of a 1970, a 1980 board or 1978 board. Which was out of production.
Is that board meant to be like snapped in or?
Yeah, so this board, do I have a picture of that?
Or do you solder onto the pads there?
No, so this is an edge connector actually that it goes into, well, I soldered the connectors on here. It's a socket connector onto this edge connector. And then that goes into onto a board connector on the computer. So like the mate of that. So I soldered these these kind of old connectors onto here, and then that plugs in to the actually to the computer. So yeah, it was a bit kind of dicey getting that spacing right, because it has to be exact. And so I was very careful before soldering it to try to plug it in and get it right. I can't replace that motherboard. It's it's 1978. So anyway, but that was a cool project, and you can look back to the June 2022 recording of this meeting, and that's where I talked about that. Let's see if I won't be able to. Okay, good. The internet was a little dicey there. So to train this, I used a PC, my new PC, but training this is not very CPU intensive. It's a fairly simple neural network model, and but I'll show you the gist of all that. So if you so this precise thing is part of Mycroft. Mycroft is this whole system that's similar to it's a kind of a public or open source Alexa kind of thing, an assistant. And so they have all the aspects you need to make yourself an assistant. And there's one portion of that code I was interested in, which is the Mycroft stuff, or the Mycroft Precise. And Precise is the wake word portion of it. So you can find this if you look up Mycroft, and I will paste that in the, I'll paste all these links. So Mycroft is an AI company, and anyway, this whole thing is you can build yourself your own assistant, and then this portion of it, it's all open source. This portion of it is the wake word listener, and that is also, of course, open source. So, and you can see the reasons here that it's pretty good. It's open source. It's accurate, pretty accurate, and languages. Well, it supports a few languages. These other ones, Snowboy was the one that was originally supported in the speech recognizer Python library, but Snowboy is no longer supported and required web, like an account on a website and all that. Whereas, and then these other ones may only run on Linux or they're not as good. You see there's it's either not open source or it's not that accurate. Like Pocket Sphinx was a popular one. Porcupine was not open source. You had to pay for that. So the only one left for me was this one, Precise. And a guy, Scott Monahan or Mohegan from the Homebrew Robotics, he uses it for Robot, his lovable little robot. that he is open source for as an easy build, and so Microsoft or microprecise is initially I looked it up and it was Ubuntu only, but then he pointed me to Scott pointed me to a link to an issue that someone figured out how to port it to Windows, because it's really Python based. So there's not a huge reason it shouldn't be. And so I got into that. And so here's the GitHub for it. And yeah, it does say, yeah, it's Debian, Ubuntu, Raspberry. So if you already are on one of those systems, then this works out of the box. And of course, as a masochist, a Windows masochist, I guess you could say, don't take my Windows out of my cold dead hands. I don't know why I like that, but anyway, because I just prefer everything in one system. That I'm using WSL 2, and so I am using Linux for the training, all that, but my robot is Windows, and so the runtime has to run under Windows. So I found, luckily that person did a nice article, and I was able to get it running. So here's just a little bit of what the code looks like. So you generally you install this this precise engine, and then to use it, it's pretty simple. There you provide a in Python, after you say, assuming you've trained a model, it ends up with it's a TensorFlow Lite, by the way, and Keras on top of that. So that's the modeling system or the neural network system. You end up with a .NET, which is a Keras, or a PB file, protobuf, which is the TensorFlow. And actually, it's not even Lite; it's TensorFlow full, which I am running on this, so it's not even Lite, but it's a light model, so it doesn't it doesn't require that much processing. So this this code here is pretty much it. You specify an activation function. You give it this. You give it this location of an engine and a file, and then it will print hello whenever you say the keyword or the hot word. So then there's some good instructions here. Oh, this is the background. If you're, you could go into a longer lecture about the neural network, but it's a recurrent neural network, which is primarily used for things that kind of are dependent on the previous state. So languages and text on a page is describing or converting that text on a page, visual, like OCR or optical character recognition, and audio. They use recurrent neural networks because of the inherent dependence on previous parts of in time with the next part to determine what the pattern is of like a phoneme or and ultimately semantics, etc. Or in this case, this is an acoustic model, so it's just taking the acoustic wave and it's taking that into the model, and it is doing some pre-processing on that through standard techniques, which is it's kind of beyond the scope of this, and I didn't study it that much, but that then gets it ready and sends it through a neural network. So some pre-processing audio stuff that's standard logic, and then it runs it through the network. So the network is called a GRU, and it's similar to other ones, or to there's another, I can't remember the name of it, but this is what it basically looks like. Data comes in, audio, and then there's a sliding window of what audio samples are being processed, and it goes through this. This is that pre-processing to get out the features. This is standard code you can just download, or that's part of this. And then the GRU is the actual neural network, and it's fairly simple. And then you have what's called a dense final layer, fully connected layer. It takes in 16K audio, and then it will output the predictions, like what is the likely, what is the percentage chance this is what the guy, this is a trigger. When it triggers, it gives you a percentage. Like I thought it was, and it was at this rating, for instance. But if it's not triggering, it won't do that. I mean, it won't give you back. Get rid of this. Okay, there we go. So now let's move on to the training. So training, you have to do a lot of recording. So they provide all a nice set of commands here that, I didn't get into my Windows port. I guess it's worth a mention. So the, where is it? Screen is kind of, oh, there it is, Windows compatibility. So I found this, a guy had branched off or had forked the repository and made it into Windows, or made it compatible. And so I took his Windows, and I even commented here as well, because there was a slight mistake in this previous post. But this is all the instructions. I don't know if anybody's going to try this on Windows, but it's totally possible. You follow these instructions. The only other factor was getting it to run the runtime on a low-powered single-board computer without any GPU. Okay, so TensorFlow normally will use GPU capabilities, and it also uses, or you can run it in CPU. And actually, that wasn't really the main factor. Of course, you can download the CPU version of TensorFlow, but the one that you download is going to use what's called SIMD instructions on your PC. AVX2, for instance. So SIMD are single instruction multiple data. So a single instruction on your PC can do vector operations, which is TensorFlow's main main use of your CPU, is to compute multiple arrays at the same time in parallel. So if your PC doesn't have the latest, if it's a low power PC, in fact mine is, I had to look it up, it only supports what's called the old standard, the oldest standard of SIMD, which is SSE. And those, luckily my board supported that, because the guy compiled TensorFlow with SSE support, this other guy, so I was able to download that and install it, and it will work on my computer, because if you install the standard one, it will just say it will not function because it's got instructions that aren't available on that CPU. So that's a thing to consider when you're trying to run these advanced, like TensorFlow things on a robot computer on board. And I need to do it on board. At least in this case, I'm not doing some sort of server thing like I showed you last month, which is of course a possibility, but I'd like to do everything local if possible. So that was sort of the Windows, that's how I got it to work. And you have to use a specific version of TensorFlow and all that, but that's all outlined in the instructions. That this nice guy gave. So training. So first, the thing you do is you collect a lot of audio samples, and let's see if I. Yeah, it's kind of hard to do this all remotely, but essentially, you create a directory here full of your, let's see, this is-
Are you saying the same wake word over and over again, different ways, or?
yeah, so I said, so here's the, I don't think I made that bigger. For instance, so what you do is you start recording, and they give a nice, they have a nice program that will, every time you hit spacebar, it will record. So like, let's see, oh, I didn't do share sound. It's gonna work.
I see. Yeah, there's a bunch of files that says, hey, orange.
Right.
57 through.
Yeah, 350. So there's 400 of these that I recorded.
You did that 400 times?
Yeah, now you can record like 100 of them in 10 minutes or 15 minutes. And so over the course of a few nights, really, I recorded a bunch of them. Let me stop share and reshare with, make sure I have audio support. Yeah, so it really isn't that big a deal to record yourself a lot. And let's see if this will. Don't have any sound. It's always tough to do sound.
If you disconnect from audio and play it over your speakers, the center speaker, the center mic might pick it up.
Well, I'm not connected to the audio of the.
Okay, then you're good.
Right. Question is, okay, you're hearing that, but that's the. It's a matter of the, unfortunately, audio. This audio player.
In your RDP, did you have it set up to transfer the audio from that machine to this one?
Yeah. Well, that's why this is the remote machine, right? That I think. Yeah. See, this is my PC, and the this is the remote audio. That's the remote machine. It seems always a little painful to get the media player to work quite right. I'm not sure why that is.
Does the media player let you select what audio to use, like what speakers?
Yeah, I might have Audacity on here. I'm not sure. Yeah, I remember having a problem with this even at home. This media player. I guess I should try to do this on my SD output device, remote audio. You can't tell like where Windows begin. So yeah, anyway, I'll suffice it to say that I recorded my lots of Hey Orange. Yeah, I'd like to play you some of these, but some of them were deep fakes and
Well, if you were to reproduce them, how would they sound like?
yeah. So but also let me get into more of the.
Do it live.
Hey Orange. I do a bunch of accents like Hey Orange, how you doing? Or I'll do my John Lennon and various accents and then just a lot of the standard, and then I'll say orange and orange, so do both of those because they're both valid pronunciations.
Yeah, Jim, don't forget about us East Coast people who speak weird. Orange, vowels,
Yeah, you got to do it in 2 syllables at least. or I'll do my, let's say, yeah, like, hey, orange. I can do, yeah, various different accents. And then what you do though, is you then need to divide all those into what's called the test set or verification set and the training set. And so here you'll see I have, so I'll record 400 and then use 20% of those as the test set. So those never get seen by the trainer. And you have to do that also for the non-wake words. So all these in here are for the test cases. And so then after you train, you run the test and see how well it did. And so what I was going to say is they have, like I can actually, this was working. Go back to my, yeah, here. First of all, I want to bring up this tensor board. It actually could turn into more than an hour lecture. This thing is kind of a long process, but so the tensor board is a web-based thing that lets you see how well your training has gone. And let's see, once this loads. Give me the link. Okay. So here you go. This is actually not that important one, but so as I trained it, and I trained it for around 3,000 epochs, which is each epoch is runs for I don't know 20 minutes or something, and or each like 6 or 7. I run like 500 or 600 at a time, and because I've got a lot of I downloaded a lot of non-wake word sounds from a library. I'll show you that in a minute. But so you can see how I've gone. So what you want to see with this vowel accuracy is you want to see it get as close to 100 or 1 as possible. And I got up to I don't know if I just did that right, but it's in the 99.9 something at this point, which is pretty good. And then the loss you want down to as low as possible. And this one is down pretty low, 0.04, it's 0.03 or 0.003.
So, Jim, I think you had about 350 recordings or 400 recordings?
Yeah, 400 of my voice, or not just my voice, wife's voice, and those deep fakes.
Okay.
And so out of those, I forget if I had 20% on addition to that. I think that was the total, and then 20% of those go into the test set.
That's what I was going to ask you, was what was your split? 80-20?
Yeah, so I did the 80-20, which is sort of what they recommend. So you reserve those in the test set, and those you don't use for training. And if some of them are missed, then you record something similar, but don't go back. Don't actually transfer the test set. I try to be disciplined about that. Don't just take the ones in the test set and put them in the training. Record new ones that are like that and train with that. So you kind of keep yourself honest. So like this is a neat, this whole tensor board is really neat. It has all sorts of graphs and, but those are, and you can see, I haven't really gotten into a lot of these fancy histograms with showing you how things are progressing. For data scientists use it a lot. Obviously, for me, this is plenty good enough to show how well you're doing. And okay, so let me close that. And what I can do, I'll run you now if I go to the, okay, that's that one. I guess we can close this down.
Did you want to take a look at our file?
So here, here's how I train. This program, using precise train, it will take everything in those subdirectories and train with them. Now, I didn't show you, so what happens is you need a lot of non-wake word. And so I was able to download from a Google, like there's some online free resources of 100,000 recordings of like 10 or 12 words. And some of those are robot words like stop, go forward and stuff. And so those are all not pay orange. And so I downloaded all those into the non-wake word category. And I also record many myself.
The ID number.
And also, there's a whole database of non-verbal sounds you can download for like the cappuccino. In fact, that one is thousands as well. And if I find the directory, yeah, these are called.
Oh wow!
Yeah, these are the words.
Where can I ask?
There's 100,000 of these recordings.
Where did you find those?
Oh, there's links to.
Under Mycroft, like the.
Well, I'll show you like all the. Oh, I didn't show you the one web page or this one user of Mycroft Precise had some good. In fact, they linked to him from the main instructions, and so this page here, he tells you need a lot more data. So this is like the on-the-ground practical guy who's actually done it. So I followed his stuff very closely and used it, and that's why I did 400 like he did. And then he also talks about using rhymes and using a website to find rhymes for yours. And I of course added those in.
You don't have any rhymes.
Yeah, you don't get any rhymes for orange.
Oh, there were like very few. Yeah, there were. What was the one? There was a couple things that sounded similar, like with multiple words, and so I put those in. But yeah, at the bottom here, or somewhere in here, he mentions you can download, these from these free sources. You can download this 100,000 of these particular words, and then the database. In fact, maybe the main instructions tell you about the database. And here's the database of nonverbal sounds from Google. And I had to find that through the download button didn't quite work. We had to look in a script and find the actual. It's in the TensorFlow stuff.
I love that exists though. That is.
Yeah, so you could download that, and in fact, yeah, I think that's all in here in the instructions for training. This is it, your training. And so with that, it actually loads so many that even on my fast machine, it takes some time. Here's how the layout is. You have your wake word and then the test and the non-wake word structured like this. And what's really nice, then this is what the training looks like when you train. And it runs through, I guess I don't have to run it, actually train it again on mine. And then to demo, you do this precise listen, and then you'll see this output. This is like the text version. And then, yeah, for false activations, what's nice is they have a tool you can do. You can run this tool on, and I ran it on the robot with the speaker that I'm going to use and everything, all as the microphone, and the microphone. And then so you say everything but the wake word, and whenever it triggers, it saves the recording to a non-wake word folder. So then you incorporate all those as the non-wake word. And then you can also just record non-wake words manually, or this one here. This is where you can download the public domain sounds. So I downloaded this this is like hundreds and hundreds of megabytes, and then you convert them to to the right format with the FFmpeg. All the instructions are here, and then you train it using this this incremental command. They give this all to you. It's really nice. These are all part of the official instructions, and then ultimately you then convert it to a PV file. But here, what I can show you here, let's see. Right, what I do is at the end here, I won't bother training, but what I do is I can do this, show you when I can run the test. So you take this command here, run the test, and so it will, I can make this bigger, right? So what it did was it loads everything. There's 363 wake words, 106,000 non-wake words, which is very important actually. The thing triggers it triggers erroneously most of the time, as opposed to it's triggering on non-wake word. That's its worst problem, as opposed to not triggering on the wake word. And so test wake words 87 and then about 5,000 for the non. So you can see these are the false positives. It has some false positives and some false negatives. And but this is what I ended up kind of being satisfied with this. Out of true negatives 5,000, out of false negatives 9, and then false positives 4. I don't know why they ordered it like this, but so it's a pretty good percentage there. 99.75%, 5,000 out of 540, and the false negatives I'm not as worried about, because then you just have to repeat yourself. Let's see. So now, yeah, I should try to get onto the. I would like to be able to play sound here. Now I can get onto the. Let me go back. I'm also logged into Orange here. This is Orange locally here. We've got all this in. Okay, I want to get out of this. All right. So I've structured this up. Not that one. This one. This one. Bigger. Control plus, right? Does that not work under?
Is that control or control shift plus plus?
Oh no, and this one is mouse wheel on this. This is a Anaconda prompt, which is basically just a Windows. But so I've set up these batch files to help me. Here's the test model. Let's see. Now I should be using this here. Test model like that. So this loads it up. Hello, testing. And you'll see some little X's. Hey, orangutan. Hey, George. Hey, John. Hey, what's your favorite color? Orange is my favorite color. Orange is great computer. Orange is a great robot. Hey, Orange. And then it activates.
Wow. Yeah. I saw it.
Hey, Orange. Yeah, I should, we'll do the real demo with the thing working. I fully integrated it. So this is your kind of test system. So this is just a test of Orange. If you just say Orange, it can activate sometimes too. Orange. But not all.
Maybe it's like halfway you were saying I did something and then it got a real long.
Yeah.
And so that would be a good negative case.
Right, well, only if it says activate. If it gets long and doesn't say activate, it's properly like, hey George, hey Orange, hey George, hey John. I used to get it. you used to be able to activate it just by making a sound like this. But I've trained it pretty well now. Orange. Orange is a good, but if you use orange in a sentence, it won't generally trigger. Orange. Orange. Yeah, there. If you just say orange, it will sometimes trigger. So that, let's see. So, and then what you do is, like, I have this listen, not wake word. So now, you only say the not wake word. So you say anything but, and if it triggers, like if I don't want it to trigger on just the word orange, then I would say orange, 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 orange. Yeah, see, it triggered there. So it'll save that to the non-wake word, and then I could, then use that.
So each of these is saving, it's kind of like storing up what you're doing.
Yeah, so it saves that in the hey, well, and the models.
So you could put this in front of your TV set, because it's never going to say it, and if it ever triggers, then.
Yeah, and that's what somebody did. They used it. In fact, they had a TV program running, and they were doing that. So this is where the models are. Hey, orange, then has those directories, non-wake word, wake word, and it just puts them all in there depending on what you're doing. And well, the other cool thing about making this easy is when you want to record the wake word, I created this batch file called collect, and it also runs a command called collect. And so yeah, I showed you listen, not wake word. I just said I like batch files on Windows. So when you want to collect the wake word, you do this, and then you run this thing. This is all part of, this ships with the system here. So here I type, looks like I lost the connection maybe. You type the prefix, hey orange is what I want to call it, and then you just hit spacebar to record, and then spacebar to stop. And you can do that really quickly and do 100 of them in 10, 15 minutes. It makes it quite easy to collect.
Have you thought about using like data augmentation for your wake word? I'm thinking like speed it up, slow it down, make it quieter, louder, put the cappuccino machine sound on top. There's probably a whole bunch of transforms you can do on those words, and you just like 100 times your wake word.
Yeah, you do that. In fact, I did have like a fan on, or my computer's fans, and I did it with and without that. And then as far as manual, and as far as like, there are tools you can get to take all the ones I've recorded and then apply those different permutations. But I was in a hurry, and I'm like, okay, 99.95 is great.
Oh yeah, it's really good.
So I was like, I just didn't get to that need to do that.
Better than Siri or Hey Google.
Yeah, if you want to, those guys are professionals, you're going to have to, do what you're saying probably. But that's weird that I can't type here. Oh, maybe it's an input thing. Anyway, let's put that. So that's sort of how it works. And now I guess we're kind of running late on time, but maybe I could do something in the show and tell. But yeah, so, well, I guess I should just bring up the final, okay. It's easier to just close this and open the room. Where's it? Actually, I can just click on. Won't need that. Start up orange. Now, orange is not, motors are not on, but the rest of him is on, and the speaker should be on. No.
Like it bleed.
So, well, I guess I didn't get into this so far. So I
Could not connect to slam.
the other thing I did,
Movement is disabled.
is, did I show you? Yeah, I showed you how to tested it. The next thing was to integrate that into my existing system. So, the existing system had this thing called,
Hello, my name is Orange. Pleased to be
okay,
your
so now he's
service.
gonna be listening. So, everything we say, if you say the keyword, the hot word, this is gonna light up. So what I had to do is incorporate the microprecise into the speech recognition Python library. And what they had there before was the Snowboy one I had mentioned. What is that? And the Snowboy one no longer works, so I implemented this. I kind of replaced it, and luckily their code was pretty similar to what I needed for they did the same kind of things, like collect the audio, send it to the wake. They already had basically a code template for what you would need for a wake word detector. And so in this speech recognizer code, I was able to add in, well, here's the test version of it, which, I guess I moved that file. So if we go to the directories at the top, tests, and test precise, test hey orange. So this is, now it's control plus. That's getting too big. So yeah, this is, whoops. So this is like all the code you really need. Listening for hey orange, and then start this process, which is creates that engine, the runner, and then starts the runner. Actually, the code is a little more complicated. Once it's incorporated into, this is sort of the full, a summary of the full incorporation into my existing system, which uses speech recognition library, which you can download. And then I had to set the rate at 16 kilohertz. And then I create this recognizer. This is code I already had, basically. Open up the microphone, and then you with the microphone as the source, you then open up a stream, and then you call this thing, which is the code I wrote. I added to the recognizer. That code is called wait for hot word, and so that is the actual thing that waits. And this is the setup here. I made a new class, a configuration class, and that you give it the model name file, and then you give it the callback on prediction callback to call when the hot word is said. So when the main thread of the program will just sit in an idle, sleeping most of the time, and then a new thread is created by the precise listener system, And so that's why here you just have while true. Where's my sleep? Well, in this case, yeah, I normally have a sleep in there, but so this will wait, or maybe the sleep is down in here, I forget. So then it'll just loop here forever, taking no CPU, and then when it gets recognized, it calls this, and so then it prints. And then here I'm using the pixel ring to actually. So when you get called back, you get a confidence from 0 to 1, and that confidence, then I'm translating that into the number of lights that appear on the ring. So as the confidence goes up, the lights, more lights light up, and then I have the last few turn orange. So and this is like a summary of the code I have in the real robot. This is like a test. I always like to write test functions, separate modules, and that wait for the most work I did was this wait for hot word, which is in here, the actual recognizer code, which is above this, I believe. No. So here, and that's a way to get rid of. Let's increase. So just briefly, the wait for a hot word, and I've started documenting it here. I lost what it was. Oh, so here's the way to get rid of the.
Oh yeah.
Oh,
just
just
click on the
click
two
this.
folders, yeah.
So I tried to be clean. I cleaned this up a bit. So Precise Listener is my top level class, and it has a to handle this. And config is the class you use to pass in to configure it. So you give it the model file path, the trigger level, which this is like, you can leave these at default, but these are specifies like the number of chunks are like 1K of audio, for instance, and then sensitivity, and then you give it the function you want to call when the wake word is said. So right, so this is, for instance, it'll say wake word. So yeah, it's the same code there, basically starting out the precise engine and the runner. I'm sorry, the listener engine. So I've broken this down further from the sample code to get more. Well, it's similar to the other code I showed you to test. So there's two main things here: on activation and get prediction. So on activation, that's when the word gets said. The on prediction is when anything is said, basically, and then how likely, what's the confidence. So that's what I used for the lights on this. So when you're talking, even though it's not triggering, you'll see the lights kind of come on to show you how close you are to the triggering the wake word. And so that's this this code, and you can see there's the sleep, the proper code, where this loops forever, sleeps most of the time, and it basically captures audio into this buffer that it then returns. Actually, this was just changing the time here. The buffer pointer's already been set, but so this will record how much elapsed time has occurred during all that, while waiting for when the wake word was detected, while waiting. So okay, so now let's try it. now if you, unfortunately it's hard to see, but the lights are coming on here. You can tilt the robot. Hey, orange. What time is it? Hey, orange, what time is it? Now it's computing.
It is Saturday, February 11th at 9 p.m. It's noon.
So if you say like, hey, George, hey, John, hey, you see it, and some white lights there.
Look over here.
That's,
This is gonna get tiring.
Oh, it's thinking.
oh, it got triggered. But yeah,
Look over here, did it?
look over here.
Oh.
and you-
Okay.
So someone else give it a say like,
Do it
who are you
over
with?
there.
Give it the command, or give it hey.
Tell it.
I want to see if other people can
Wait,
use
what do
it.
you want me to do?
Give it a
Say it
command,
over.
like what, who are you with? You have to say hey.
Hey, orange. Hey, orange.
Go a little slow and move in.
Hey, orange. Hey, orange.
That's it, you know? I didn't have enough.
girls yelling
voices. Now it's gonna say I don't understand that, probably.
Sorry, I don't understand. Hey, Orange, we're out there is going 6. I didn't have enough female voices.
There's your comedy.
Or did you?
Yeah, give it a try, Alan.
Hey, orange. Hey, orange. Hey, orange.
Oh, because orange is really a 2-syllable word, I mean, I'm kind of
okay.
banking on that,
Okay.
so try to give it the
Okay,
full
got it.
2-syllable.
Hey, orange. What's up? What's up? Hey.
Hey, orange.
Oh.
You got it. You got it.
Sorry, I don't understand WH.
Give it a command, like say, what time is it, or who are you with, or status.
Hey, orange. Status.
A little slower, because can you see you probably can't see the rings. You gotta, as you speak, wait until you see the orange color. Can that thing see me?
Hey, orange. Status.
Turn off sharing? Here, let's,
You almost got it. This is tough.
Hey, orange. What time is it?
Wait, I could use my my own camera, right?
yeah.
Okay, try again. This is gonna get tiring.
Right there.
Hey, orange. What time is it?
No, you waited too long. You gotta.
I can't see the rings or the lights.
Oh, yeah, your camera's on.
Yeah, my camera's on. I can see it.
Yeah, he's in the
He's
top
there.
middle square.
Yeah, let me show you. Let me demonstrate.
Middle.
Hey, orange.
Oh,
Hey, orange. What time is it?
here, let me show you the cadence. Or it's not. Hey, orange. What time is it?
It is Saturday, February 11th at 13 p.m.
You see how
It's noon.
that timing is reasonable, but I guess it's not like.
Universal.
Yeah, the way I do it is I'm waiting until I see the ring lights go all the way up. So yeah, anyone else want to try?
Hey, orange. What time is it?
Try again. Sorry.
Hey, orange. What time is it?
It is Saturday, February 11th at 14 p.m.
Try, yeah, try again, Thomas.
Hey, orange.
Like that. I'm sorry.
Hey,
2
orange.
syllables.
Hey, orange.
It's trickier than this.
What time is it?
Works great for Jim, but.
No, you try it.
All right. Hey, orange.
You gotta give it.
Hey, orange.
You gotta give it a command after that if you want it to do anything.
Who are you with?
Sorry, I don't understand. You gotta give it back. Orange gotta give it a command after that if he wanted to do anything.
Okay, try. Hey, Orange, who are you with? Ah, that's what Orange is.
Try again, let me try again,
We
or,
all try again. Hey, Orange, who are you with?
I'm with Jim.
there you go, works for ladies. Fine ladies.
Yeah, that's funny.
Cool. So, yeah, well. Yeah, so that's, there's more, there's obviously a lot of, this is quite a big topic.
Oh, yeah.
But the basic idea, the only other thing I mentioned is I had to, my previous thresholding system, the ambient threshold for the famous aquarium disaster where the robot couldn't hear anything. And then there was existing code in there to sample the room, essentially sample the audio through the microphone when there was nobody talking, or it kind of guessed when there's nobody talking. With in their code, with this speaker microphone array, there's a bit that tells you when it thinks someone is actually talking. So I use that bit in there. So now what I do is when nobody's talking, every 10 seconds, I time out the listener. So it comes back to my code and then does a threshold. It records 1 second if there's no one talking, and then sets the threshold. So if you have like a sound, now the threshold went way up because that is a constant background noise. And then what happens, that is a key information, so that then it will dampen.
So you're saying if it hears that clapping noise, someone can still say, hey, Orange,
Yes,
and it should be able
yes.
to get it?
Well, mostly, the main benefit of this, or the main reason for this threshold thing was to know when to stop recording.
Oh.
Because what happens is, if there's a background noise and it doesn't know that it's there, then the code, the recording keeps going on forever because it thinks the code. Actually, I should change that, but the code, the original code in the recognizer is just using the volume to determine if there's someone still talking until the phrase ends. But I have a bit now, which I'm using elsewhere. So I think I should just use that bit from the speaker itself. The microphone itself has a bit that says, I think someone's talking. I could use that bit as well. So this is still an ongoing process, but this, at least with this system, or the way it is now, I have that threshold in. I thought it was doing more than that, but like it was actually able to use that number to help suppress or to distinguish the voice. But it's mainly just for the cutoff when it stops recording and says that's the end of the phrase of the sentence. That's the end of the command essentially. But it works pretty well. But I'll add that bit into that other code there so it also uses, because what it does is it says, okay, here's the threshold. If the threshold, I'll know when speech stops when it drops to below the threshold or whatever. Actually, the threshold is what the ambient noise is. So if it drops back to the threshold around there, if it's not above the threshold, then it says, oh, there's nobody talking anymore. It's just using the amplitude. But with that bit I have, then I might be able to just not get back to this. It's pretty reliable on this thing. But yes, when that little red light is on, or no, it's better than that. So anyway, so I incorporated that, and
Hey guys, we can't hear you out here. The audio is really garbled. Is it just me or is there anybody else having trouble with the audio? Tim's having trouble with the audio?
It's all garbled. I can't understand hardly anything.
Something went haywire.
I'll try to log you back in.
Tim, can you hear me okay?
I'm sorry, what did you say, Tom?
Can you hear me or not?
I can hear you, but everybody else is garbled.
They're all garbled, yeah. Seems to be getting some feedback too.
I'm gonna mute myself.
Come on, Alan, figure it out. They can hear us, I guess.
Can't understand a word you're saying. Even I sound garbled when I talk.
Yeah, there's an echo problem too, Tim.
Oh, yeah. Gotta do this, the frowny face.
Yeah, this is the same thing
Oh, is
that,
it paused?
You fixed it, guys. It's working. I don't know what you did, but it's working again.
Now make a smiley face.
You're back. You're back. Hey.
don't move. There you go.
What'd you do, Alan?
I didn't do anything. That's unfortunate.
It's a network fluttering or.
Start show and tell if you want to start the recording, Alan.
Done.
Awesome, thank you very much. John, let's hear about this contest idea.
Okay. I don't know why my screen isn't showing up big.
It is on my, there you go.
Okay, good. It requires a field. Okay, I've got to get rid of my background. Sorry, I'm going to cancel that. Video settings. Background and effects. How do I get rid of this thing?
Nice.
Always a little humor. Okay, there must be an option for none.
It's on the, by the camera icon. You see the camera icon on the bottom left? You see the, John, do you see the camera icon?
Yeah,
bottom
but
left?
it's, oh,
You gotta turn off
Yeah,
the,
turn off your virtual background.
So the camera bottom left is the stop video, but it has a little tick mark. If you click that, and then there's something called blur in backgrounds. Or no, choose my virtual background.
Oh, choose
From there-
virtual background. Okay, I don't want any. I've got that screen up, but
One of the options would be none.
oh, there it is. I didn't see it at first.
There
Okay.
you go. All right.
Yay. All right.
Okay.
This is a scrap sheet of regular printer paper. 3 dots encircled around them. And this is a pretty inexpensive field. The contest is for a robot to draw a continuous straight line, as straight as possible, between these. And obviously, following my image on the screen, I'm not succeeding very well.
Just like our robots.
Exactly. And now I'd like to show you an example of an actual robot attempting this task. So let's see if I can share my screen. I've got it all queued up. Okay, share screen, and then I have to pick the screen. I don't know what's happening. Oh, here we go. Okay, this is the screen I want.
Okay.
And I hope you're seeing a robot in motion, are you?
Yes. Lego Mindstorm?
It is. I meant to show you the bad example first, but somehow I got on that one. Okay, let's try this time. Okay, this is my first attempt some months earlier.
So what is it using to find the dots?
Oh, it knows the coordinates of the dots precisely. It's like a Magellan contest with waypoints that are known, GPS points. There's no mystery about that. If you think, yeah, if you think it's easy, okay, I'm going to try to stop sharing my screen now.
you can show the correct one again. If you want to repeat it, that's fine.
Okay, I am screen share. Oh, pause share. There we go.
You can repeat it if you want.
Oh, I found it. There we go. And what's going on? Oh, there we are. All right. You think it's easy, right? Should be trivial. The contest would be just draw that line anywhere you can. I used a robot arm, but you can imagine a small bipedal robot dragging a pen if you like. Or a little two-wheeled robot. I think you'd find a challenge, though, in mounting that pen precisely on the axis of rotation. The only rule would be that the 3 dots themselves can't be in a straight line. And you can have more dots to make it more interesting. And the winner would be the one who draws an acceptably straight line in the shortest time. There, that's it.
Okay.
That's interesting. That's a good idea.
The original Turtle bot was that exact same concept, right? All logo and everything was based on a robot with a pin that drives around. I like it.
But
So
this
that-
one, you have to know, I mean, this is essentially a robot with an arm, and an arm that has to go to a precise location.
Not necessarily.
Maybe, it's whatever you
You
want.
can just, you can,
That would be
Facebook.
easy if that was just the go to a location, but it has to draw a straight line between the waypoints.
so you can use, the McQueen with a pen
Uh-huh.
and have it drag the pen around behind them or something,
Oh, so just drive and drive the whole thing in the
dragging a pen
straight line
or something.
and then to the destination. But it has to hit the coordinate. That's the
It's gotta
coordinate.
start it in at the dots. So if you had a pin dragging out the end, if you turn around, it's gonna give you a big arc, so that would be a problem.
Yeah, you gotta account for that,
Yeah.
the size of the bot.
Unless you put it right in
Tricky,
the.
as you think.
You can have like if I have
A little
I have a little scoop that goes up and down motor, so I
Just a
can
little
lift the
servo.
pen.
What if we draw all over the ground here? Not that I would.
That would be the last one to let us.
Right, so that-
We'll just make a mat bigger than the paper and be ready to grab the robot.
Yeah.
So yeah, but he's saying it's a bit, you can choose whatever robot you want, right, John? I mean, it's,
Right.
It doesn't have to use an arm or whatever. It can be anything with a pen.
Mhm.
And the pen can come up and go down, or if you want to have like a plotter.
Pen, Sharpie, whatever you got.
I mean, the Sharpie, whatever, can be lifted when it's, and then when it's not drawing, and then go down when it needs to draw.
So does it have to have like a home where the robot has to start or be sitting on at first, or can it, is there like
Yeah. Yeah, that would be,
or anywhere?
it has to start on one of the dots.
Okay, it starts on the dog.
And I would say probably.
Yeah, one of the,
Or, no, honestly, because orange might want a big play field because it's.
Oh,
I
it's
use
something
the orange, yeah. I'd
Yeah,
use
so if you used orange, but if you used that little Lego Mindstorms, you might want a real small play field.
Yeah, that's true.
Bring your own
You need
box.
to have your own, well, obviously you're gonna practice at home on your own setup, so bring it in, right?
That's a good idea.
So really, it's, man, yeah, you have to go in a straight line, you have to apply a pen, you have to hit the target at the end of that line.
John, I think this is a good idea. This
Yeah.
is the most discussion I've seen about a constructive discussion in months. So I think a bunch of
This
us
is a
are
good
gonna go
one.
back and.
yeah, well, I hope it'll inspire others to come up with good ideas, because we need contests.
Yeah, we do.
I like the idea, just, when I get a big penalty, I wanna draw a line, but then I'm gonna wander around to the other side and draw some gibberish while I line. Is that a penalty? Because I don't wanna do the line up, the pin up down mechanism.
Yeah, that's the thing, if there's extraneous lines or drawing, does that decrement your score?
If you draw something that isn't supposed to be there, sure, that's,
I get a penalty.
It's a penalty, but you're not disqualified.
The points don't count.
Get the clothes.
Points don't count.
Inappropriate drawings get extra points?
Well, you don't get appropriate drawings. Well, also, you said it's the time, the main test is the time to finish correctly, right?
oh, right, time to plot correctly from, I can see there has to be one more rule, and that's which is the home place, the starting point.
So you originally said, it has to start in one dot or start in like a corner or somewhere?
Oh, that's up to you. You have to
Well-
draw from one dot, the home dot, we'll call it.
Yeah, so It has to be universal because, for example, like his Mindstorm, it didn't seem to have wheels. So if home is like over here, it might not reach the dots. So
I think for this group, really, start where you want to start.
Yeah.
If I were to start in the middle, mine would start, I'm gonna probably use a wheeled robot because that's what I do.
Yeah.
Also in the corner somewhere.
okay, so start wherever you want and bring your own dots.
You have to find the first dot and the second dot if you start off of
So
the
you could
first.
sit on home dot.
I was starting, I
No,
made
his-
it really good and, you know.
So
If you
I
want
guess that's-
if you want everyone to use exactly the same field, just
Yeah,
make
I
a PDF document and let everybody print it.
No, because
Don't-
like depending on what size of robot you're using, if that might not work. If some robots might need a smaller field, and like for example, orange or anything
Well, the orange
bigger.
could draw an 8.5 by 11. We're not saying, we're not saying that the robot has to be in it, like, give them a little.
Yeah, right.
And I like this contest idea because even people online can do it on their tabletop and point the camera at it, show us while it's doing it online on Zoom. So this is a good idea.
It's Zoom compatible.
It's Zoom compatible.
I like it.
Mhm.
All right, I hereby anoint this contest, connect the dots.
Connect the
I'm very excited right now.
The mouse is trying to follow that dot over there.
Come
Thank
on.
you, John. That's a great idea.
Good idea.
That's cool.
How-
I like that, John. That's a pretty cool idea.
So
Thank
Should we
you,
do-
thank you. I'm done.
2 months from now? What do you guys say, 2 months from now?
That seems reasonable.
Yeah.
You know,
Good?
Yeah.
All right. I'll put that on my notes and maybe we can post it on the website, Alan?
Right, logistically, we do it right here.
Or we can do it on any tabletop, depending
tabletop.
on, the size of the robot, out of in the hallway.
Dry erase marker.
That's all right. That little line, don't worry about that little line.
And there's many ways we can make it much harder.
Yeah, you can.
Find the dots and Alan draws the dots, so you can draw your own dots.
Well, what you're given is the location of the dot you have to get to, I assume.
But I think as defined, it's just the right level.
Yeah.
We could all do it, and then we could like maybe have an advanced one, like we do with the color line following.
Yeah, we could do that. Let's get the first contest.
This is cool.
Let's get participation for one.
And we do expect Pepito to draw.
In 2 months, can you get Pepito
Come on,
up and
man.
running?
Oh, geez, I'm just, final assembly is right around the corner.
He's got hands and everything, it should not be a problem.
Right, just walk around.
You can help him balance.
Oh, that's right.
It could be his tail.
You can use it, yeah. Tell. You might need it with the backpack that heavy.
That would be cool.
Extra points in this bipedal.
Oh.
You just win right away.
You just win.
Yes.
All right, April 12th. Connect the dots contest. Cool, okay, thank you, John. Next, show and tell is Alan.
Oh, okay. I'm going to share my screen. So this is super quick. It actually came about from a conversation we were having during lunch. And when I ordered the boards and I got my boards in, I'm like, gosh darn it, this is the smallest thing I've ever seen. How can I possibly solder these? This isn't going to work. And then Ben suggested solder paste. And so I ordered it through Amazon. It came in today. And then there were some questions about what that looked like. The whole concept of stencils and reflow and hot air guns. So I just thought I'd pull together a couple of clips that for people who have never seen this before, what it looks like. When you order PCB, a circuit board, for most houses, they have an option to purchase a stencil. It's either plastic or in this case metal for a higher quantity of circuit boards. And it laser cuts out everywhere where there's supposed to be solder. And let me scoot forward a little bit. You set your board down, and then you align where the solder is supposed to go, and tape it down. You lay down a little bead of solder, and then and then you scrape it over. So the amount of solder depends on how wide the metal is, and it's the perfect amount of solder in the perfect spot every time. And it's super precise and super easy. And between this and a little trick by using a toaster oven to melt it, you can do these things for a very low cost.
Oh yeah.
And there are a couple of things that will kind of save you. I found a couple of quick clips that shows you what it looks like during the reflow process. So there's about 3 or 4 temperature settings that it works up to. And whether it's being assembled, automated through a pick and place, or using a pair of tweezers or anything else, you don't have to be super precise when you place it because of what the solder paste does when you heat it up. The best description I think Brian had was just surface tension. So check this out. You've got some solder paste spread over, not super precise. You placed a couple of components, again, not super precise. But check this out, as it reaches the melting point of the solder. Wait for it, wait for it. The surface tension of the solder pulls it in place. The surface tension also causes the solder to pull away from cold joints, and there's still a few there that require some cleanup, but all of the surface mount capacitors, resistors, and the IC chip just magically go where they're supposed to go. I've got one more quick clip just to show you, and it is really magical when you see it happen for the first time.
Now the chip, the component is moving a little bit during this.
Yeah.
Would it move too much?
Just sucks it right into place. Alan, can I say something?
Yeah, sure.
I worked for a company where I actually did this thing. It was a little bit tricky to get set up, but once you get it set up, it just like sucks it right in.
Yeah.
We even had the oven where it went through a profile and kind of did down. So you stick it in there, type in the profile, heats up some solder. You can watch the chips if they're a little bit off, all of a sudden they line up and it's perfect when you're done.
So this one is not even a mask. Someone just
someone just used a syringe, right? Just kind of it all over.
Oh, so even that will.
But the solder mask is a little bit tricky to set up, but once you set it up, once you got it down, how to do it, you just sit there and crank them out and put the parts in and, solder, put them in the oven.
Now, when you say cleanup, do you have to go then with the magnifying glass?
Oh, look at this guy right here.
Oh, yeah.
That was.
That didn't work.
So what happened over
there? That one went up. Sometimes it doesn't. Does weird things. But even when you get this soldered, if it's got bridges on it, stuff, you can sit there and take a little solder away, suck it right out.
Yeah, and this is one of the, so this one was done by hand using a syringe, and sometimes there's some cleanup work. So you can take a fine dewicking braid and clean up where it accidentally bridged. Now, when you use a stencil where the amount of solder is carefully controlled based on how thin or thick it is, you don't have any of these issues.
This is
something
not
you
a
see
problem.
a lot more often when you're doing it by hand.
So the stencils.
Yeah, and so getting back to, to make it up close and personal again. So I'm gonna, everything came in, I've got a syringe, I'll pop the components in, I'll place paste down as thinly as I can, and then I'll hit it with basically a hot air gun, and anything that oversteps or bridges, I'll just clean up with a soldering wick. There's not a lot of space between these, but that solder mask won't keep it from bridging over it, but it'll prevent most circumstances from individual contacts to bridge. So,
Can A flux pen is your pen.
Yeah, there's also flux in the paste, but yeah,
Yes.
for solder, I also ordered those just in case.
Are you going to be doing your through holes with the solder paste?
Yeah.
I just never seen that. I've never seen it
I wasn't
before.
No, it can work. I've done it. I've done it.
Yeah, I've never seen it, but it
Yes.
makes sense because it's gonna suck down into the holes.
Yeah, and I also
Should
ordered
work.
0.5 millimeter rosin core solder, and I got a flux pen. I got a couple of different ways, but I'm really hoping I get away with that.
Why not just
No.
2 holes?
Alan,
Yeah.
if you, I have been able to hand solder one of these things with the pads or IC pads or the thing. Usually I use it to tack down the corners, but I can actually, well, what to say, small fine tip or fine solder. I can individually solder the thing, so it works really good. A little bit of practice to get it down, but once you got it down to a technique, you just sit there and crunch on it.
I personally can't do that. Justin can do it, but he does finer pitches than what you're showing here, but
Well,
I
I've
don't know
got
how.
30 years of experience soldering, so.
Oh, no, the fine pitch like that
Hi, Sergey.
Some people do that manually, like I saw it demonstrated, and this guy, well, yeah, he did a resistor, but it was just like, bloop, bloop, and he did it by hand. Why does anybody, well, if you're working, say, on a vintage computer, board, where you have to do repairs, and it's surface mount, you have no choice in the matter, you have to do it by hand.
Yeah, hot air rework tweezers,
So that's where you need the tweezers, so, but if you're making your own new board, you can get the stencil made, and all this is kind of moot.
Oh, no, I mean, as Alan said earlier, once you get the stencil set up, you get to the point where you just sit there, swipe it over it, you can mass produce a whole bunch of them pretty quick.
Yeah, and I also purchased everything to do it by hand. I have a fine tip temperature controlled iron. I have 0.5 millimeter rosin core solder and a flux pen. So I've got a couple of things, but I'm really keeping my fingers crossed that if I slather it with paste and hit it with that hot air gun, that I'll get away with it.
You bought a full backup.
Alan, the one thing with a hot air gun, if you get it too close, you can blow the chip right off the pass.
Yes.
You gotta get it the right height, the right temperature, and then you can do it. But actually, we bought a special gun that's made to do that sort of thing. Down the temperatures and just hold it a certain distance, everything, and just sucks it right down. But again, doing what you can do can be done with a hot air thing, but it's really tricky. If you get it too close to the thing, you blow the chips right off their solder pads. And believe me, I've done that about half a dozen times before I got it just right.
Yeah, and if you think you're going to find that surface mount component after it's blown off, you are mistaken.
Depends how you have it set up around. I had it set up to the point where it wouldn't blow off the bench. So, but yeah, it gets hard to find.
Smarter than I am, then. I can't tell you how many things I've lost in my office with a hardwood floor. Where can it go? It's still going.
Oh, yeah.
They get sucked into the icy black hole thing.
Yep. Like socks. All right, that's all I wanted to share with you guys in case no one else has seen it. It's super cool. And regardless of the outcome, you'll definitely see the results next month.
And I'm not sure if I heard you mention it, but I got a soldering station. It's a hot air rework station, and I've never successfully used it for that. I just use it for heat shrink, but it comes with all the settings, the heat and how fast it blows. So you try not to blow it away, and different size heads. So that's that's the tool to have if you really want to get in.
Yeah, my friend's got one of those. He's got really good at it. I mean, I have been wanting to invest in one. I have a Weller, temperature controlled soldering station, but the other stuff's better.
I just got a cheap knockoff one. Yep.
Well, I got a nice one actually. But
Very cool. Thank you, Alan.
It was really good, Alan. Thank you.
Oh yeah, my pleasure.
Want to see how you make out with it there. If you want to talk to me offline about technique, I can help you with it if you get into a problem or something. Because I've done it a lot. I did it with one company. We're making all these custom boards and stuff. Because it was so cool to see something I breadboarded up, turned into a circuit board that's small enough to stick in something that's small.
Yeah.
That's sort of cool.
All right, so up next is Jim.
Okay, so, what I brought today is because of some of the guys here are touting their new SLA printers. I wanted to reinvigorate the fused deposit printer.
Oh,
And,
you're sharing front and center, so
Oh.
let's
I can turn that off.
yeah.
Well, it generally shows your picture.
Yeah, I'm gonna spotlight you. Go ahead. Yeah, you're good.
But yeah, I'll show. So, I'm using this filament. It's not as, actually, it looks better if you shine a light on it, but it's a dichromatic filament that is, or prismatic, you could call it as well. And you can see, get rid of, it's on the screen. You can see it has quite a shimmer to it, especially in sunlight. So this is also using what's called vase mode, and I'll show I'll show you what the settings need. But the first thing I want to point out is
you can see a little degree.
Yeah, as we rotate here, you'll see the vase changes color, and including even inside, you can see like on the inside portion, looks like it's all green now. About like there, and then as you rotate, it transitions to a new color.
No, the inside and the outside are kind of like inverse.
Well, see, they're the same color, like this. Oh yeah, as far as the spiral.
Yeah.
But the color's the same, and as you switch it, you get like a combination. And then here's, let me show you the first one I did was this one. This is even shinier to some degree. And so you can see it's a green vase, inside and out, really. At the right angle, you can't tell there's any other color in there. And then you rotate it around, and now it's totally raspberry. This is the raspberry one. Wow. This is called Mata Hatter's prismatic, dichromatic filament. And here's some more examples. This is a really cool vase as well. Same idea. I found the kind of the best ones that I could find for this demonstration. But it's so much nicer than your old. And here's just like a Phil Ament. His name is Phil, and so he's like the example that they have on their website, the Mata Hatters. And then, that all compared with your standard, it's not quite as, this is a standard PLA plus red.
It's not red, so look left in the sun.
So,
yeah, that's a cool filament there.
Yeah, so this is really cool. The backstory is I was having, it took me a week or couple weeks to get my printer working again, because it was like suddenly not working. It would fail on prints like halfway through, and I was with the Prusa people trying to figure out it was a mechanical problem with the Z-axis or Z-axis binding, if you've ever heard of that, where it's the Z-axis kind of stops going up, and I photographed it and videotaped it, and just at some point it would it looked like it was going up, but then the head was staying in the same location, so it was just digging a trough and trying to output filament there and causing a disaster. And finally, I decided to use this Pronterface software, which is, instead of using an SD card with your file, your G-code file that you plug into the printer, this Pronterface is from your laptop with a serial connection to the printer, and then you load the file in the interface and say print, and it sends the G-code over serial. The problem disappeared. So now, and I found out, or I remembered, last year at some point I was having card reader errors, where it would just stop the print and say I lost connection with the card, and it was kind of a flaky connection. When I put the card in, it would say card not read, card read, and then so I looked it up, and the solution was open it up and kind of bend a pin rather than replace the whole thing, because that's the whole display board assembly with the card reader soldered on the back, so you have to replace. So I fixed that by bending this pin in, and then didn't get any errors anymore. So the only thing I can think of is there is a subtle error that's not triggering the hardware to report a true error. So it's under the radar and it's corrupting the data. As the G code is being sent to the printer, it actually skipped ahead, I think, or got to the wrong offset, because I noticed it doing a move that was like, that move, if I look in the G code, was somewhere else, a different layer. And so anyway, so I may have to just buy a new assembly there for that.
It was multiple cards, same issue?
I haven't tried, but this is a brand new card and I ran it through Windows and no errors on it. I'll try another card, but I'm like, I can't, why would that card fail? It was a new card. That was the other thing, I bought a new card because it didn't have that problem. You know, the old card I've been using had that intermittent connection problem. I got a new card and bent that pin in.
What size of card was it?
These are SD cards,
Like
100 gigabytes. I think, I don't know, 64 gig or something.
Oh, I don't know if it's the same problem.
Maybe 32 gig, yeah.
I don't know if it's the same problem, but I had similar issues with one of my printers that I threw in an SD card, I think it was a 64, and didn't read it. I got a 16, didn't read it.
Oh.
Once I put in a 2 gigabyte, it read it.
You're right, but you got errors though, you know, it reported like, I can't read this.
It just didn't show anything.
Right, okay, but yeah, mine have been working fine and I got the same capacity, I think, as the old one, but I'll try the other card.
Depending on the firmware that's on there, it might have or the board that's on there, if it's like an 8-bit or 16-bit, I don't know what's on there. It might have a limit on the size of card.
But then it would have broken from the beginning, not like suddenly stopped working. Sure. So I'm asking the other, so just as a comment about original Prusa, they do have good support. Even 5 years after I bought this printer, they're helping you out. But of course, they're saying all these things that aren't really, I mean, you know, exactly that helpful, or that's somewhat helpful, but not really knowing what the problem is. I mean, they were saying, you know, check the trapezoidal nuts. So I learned more about my printer than, you know, I did before, checking all these different things, and those, like, hopefully didn't break anything while checking those, because that wasn't the problem at all. Anyway, so that's a story of getting frustrated with 3D printers can really happen, and you're like, you throwing away plastic, and you're like, nothing's working, and you're like, I want this expensive thing, what the heck? You know, I bought an expensive one, and now it's not working, and there's like a million things can be wrong. It's a complicated machine.
It's a never-ending process. You gotta maintenance.
And then so I did. I re-greased the you know, the Z-axis pole, all the poles. Did a full calibration, XYZ calibration. Did all that stuff. Layer 0, layer 1 calibration. So the thing is in tip-top calibration, but the software or the reading got me that time. Anyway, so that was very frustrating, and the guy never suggested the card. It was only me when I thought, this Prontoface thing, let's try that, because I actually like that Prontoface because it shows you a diagram of what's printing. It's pretty neat. If anybody has a chance to try it out. So VOS mode, just to show you, spiral mode is the slicer setting that tells your printer to print from the outer edge of your model in continuous single extrusion. So this vase here is like 26 meters of a single bead, never broken, all the way through one thing. Oh, and I'll pass these around now.
Is it like just a layer, like just, it doesn't have like a inner wall?
No, I've got these all queued up here. So in the Prusa slicer, the spiral rose requires one perimeter, no top solid layers, 0 density fill, no support material, and then this other thing, ensure vertical shell thickness, enable and detect thin walls. So it's a single wall the width of your bead.
The nozzle?
The nozzle, basically, yeah. Oh, here's the other one. Has-
And then the way feel.
And, yeah, so that's that, and then in my system, this was for, oh, and this is an example of, when you don't use Vos mode. Normally, this is the benefit of Vos mode. When you don't use Vos mode, you get a seam in all of your prints, so you can see that.
So does it go back
seam.
and forth like this?
No, it's one direction, so see, can you see that? You can see right here, there's a
Here.
seam.
Here, let me give
Oh,
you.
well, they can see it in the side-by-side, can't they?
Yeah, it's
Very,
up
very
small.
little.
Yeah.
Oh, it's very little. Yeah, why don't you, or you want me to stop share?
There you go.
There you go.
Okay, so the seam is nicely hidden in this corner, but there is a seam there, right there. You can see it in the light. See how that's not smooth? In Vos mode, yeah, you can send that for comparison. Vos mode, this is not in Vos mode. This is just a model with infill and everything. So Vos mode is a continuous deposit of bead, gradually increasing the Z height every second. Every second, it's going up by 0.05, 0.05, 0.05. So it's a one-directional thing. You can only have one wall. So it's a spiral. It's literally, the printer is going in a spiral like this, all the way up, depositing as it goes. And so you get a seamless print. There's no seam in it.
But why is it, what's causing the seam?
So seams,
It goes and then it lifts another
yeah, so for
millimeter?
seam, this one has the seam too. Seams, it will go around, it goes around like this, gets to it goes around twice or something, then it goes a little
Oh,
dip, a little
tips
up
up.
and down,
Mhm,
and then it goes to the next layer.
Got it.
So when you do that little up and down,
Yeah.
you get a seam. So this is the beauty, so I definitely want to make sure I point that out.
So you're gonna make one of these without the seam, is what you're.
That's what that is. The other one, the prismatic one is.
No, that one has a bigger seam than this one.
Oh, I'm sorry. Well, basically, yeah, I might have forgotten, but these are all seamless.
Yeah, these ones have no seam at all.
Yeah. The other advantage, Bob,
I might have
okay.
forgotten on that one.
I was gonna say the other advantage of Vos mode is you can give it a solid shape and it will just trace the perimeter. So it doesn't have to be a hollow shape, which you did when you didn't use the Vos mode and the seam, you had to have it a certain wall thickness. But if you give it a solid shape, the Vos mode will just trace the perimeter automatically.
Yeah. In fact, one of these vases came with a solid version of it, and you can use that, and it automatically changes the settings for you to topless, no top, and as well as no infill. So, and only one perimeter. So you can do this to pretty much any object that has a consistent exterior like this. Yeah, does that one? So that one. Oh, the reason that
This
one.
has got a big seam.
That one has a seam because that was not in Vos mode. And you can see that like these two here are thicker. Notice they're not, this is not one bead thick like these. This one you could crush with your hand, with your pinky pretty much, because this is a single bead. These two are, see how thin that is versus this is thick. So yeah, so if you need to have a sturdy vase, you're gonna have a
I'm
seam.
working on it.
But anyway, so yeah, thanks, and yeah, that's how you do it in the Crucis slicer.
That's pretty cool, Jen.
That's super cool.
Very cool.
Thank you. Yeah, and the link it's called let me get the link here. For the prismatic filament, Mata Hackers, Mata Hackers, and under
Quantum, it's called Quantum, I guess is the brand. This is the brand I bought. And
Oh,
I
I
like
shared
it.
you. Go ahead and share yourself again.
Well, I'm gonna paste it.
Okay. Okay.
If I find yeah, right here. So I'm pasting in the chat. This is the link to the Matter Hackers store. And they had a discount after Maker Faire. So if you want to wait, they may be at the next Maker Faire and have another discount. But it's pretty affordable. I mean, so if you
Even the
go,
solid color looks really.
yeah, this
still
is
looks really nice.
right. That's not from Matter Hackers. This is PLA Plus from I don't know which company that was from, but yeah, if you want to share that, thank you. So yeah, I'm really happy. I got these done just in time, fixing the printer only a few days ago.
How long did they take to print?
See, that's the other thing.
How much was that?
This huge thing took 3.5 hours. If you do it with regular mode, 9 hours.
Oh my god.
How much was the spool?
I think the spools are like 26.
Yeah.
I see. Alan's on it right now.
Yeah.
30. Yeah, and I only got one, this raspberry green. I kind of wanted to try some other colors.
So if you search on Amazon, color changing PLA filament, you get a whole bunch of different types of them.
What do you color changing
Filament in Amazon?
How did you figure that term out?
Because that's how I bought mine.
Oh. So this is just a brand that I got noticed at at the Maker Faire. That's
yeah.
But yeah, there's plenty of them.
There's a lot of different brands that do the same thing.
I like that these are particular. They're dichromatic, so there's two beads as opposed to I don't know if all of these are two beads or there's rainbow ones. Rainbow. But it's two beads and it's prismatic, so. I don't know if that's just the same thing, but these guys do a good job. But yeah, check out Amazon and see what else.
Oh, they have one that's even glow in the dark.
Oh, nice.
Color changing glows in the dark.
Eating one that I haven't used it yet, but in the heat or in the sun, I guess it.
I had that one
different
too.
color.
Oh, really?
Yeah, pretty much. So you can put it somewhere cooler and it's all.
That's like a chameleon. I've got to do a chameleon model in that filament.
That would be awesome.
But yeah, it's pretty fun. I hadn't used my printer in a while, so I wanted to do something interesting.
I want to drink that.
Yeah.
Those
you can make them.
Osmo would probably be more watertight than the other ones.
These will.
Yes,
these tend to be
there's no seam, so it's probably.
That's true.
A lot more.
But these are so thin. It's like sometimes there's a little tiny micro hole. What I do is if I want to use it as a real vase, I spray a sealant inside and just go because it's called fixer. It's fixer like what I used to do like charcoal drawing on paper, and then if you want to fix it or pastels or something, you spray this. So I have this can of stuff that you spray on to fix it so that it won't smear anymore or whatever. And that same stuff. So it's an art store thing. And you just spray that. I sprayed it inside, and it got rid of the leak on a vase that I was using, and I used it as a real flower vase. Cool. But I haven't done that to these. These are kind of a little too, not much weight.
You hold like one flower.
It might work.
I guess if there's water holding it down.
That's true, water, yeah. Yeah, there's water, so, but I'm gonna try that spraying that fixer stuff in and see if it makes these waterproof. Cool.
Very nice.
It's a non-toxic, it's not really.
Anybody else have anything for show and tell? Anybody online? No? Hey, Sergey, I see you there.
Sergey.
I just have a quick, I made this little guy I just assembled him, a Radio Shack. I don't know if you can see him. but I was
Radio Shack.
a little R-bot.
Yeah. Not no.
And then I don't know what happened, but the little, I call it a little joystick. I don't know if it has a short in it, but he doesn't move anymore. I used to get him to move. I don't know if anybody has any pointers, but he used to move with these guys.
Oh, with those, under the joysticks, they have like, little contacts.
Oh,
That might be-
yes.
You take it apart, you might find something that's worn out in it.
Yeah, maybe I'll take it apart with a little Phillips screwdriver.
Little cleaning maybe. It might work.
Be worth a shot. It's kind of hard to tell if the problem's with the remote or with the robot, right? So you gotta
Right.
like down into pieces and eliminate one piece at a time. Sounds like a fun little project.
What is that? His space.
It's a fun project, indeed. I might try to put one together again. Thank you so much. I tried to find the same one on Amazon. I haven't been able to find them because the last time I put them together was when Radio Shack was a business, and they are not in business anymore, sadly.
Radio Shack, Fry's, Silo, Circuit City. Oh my gosh.
Oh, wow.
I know, right? All the good guys are gone. There was a very nice young lady there who really helped me, and she was so instrumental in getting me going on my R-bot. And I named him Barney.
Oh, they still have them.
They still have them? I hope to find them.
Xbots were part of Radio Shack, right, originally?
Oh,
Or was it- I guess-
Xbots, yes. I looked that up.
X.
Oh, Hexbots, yeah, and I think.
Oh,
they still sell-
Xbots.
Yes.
Radio Shack.
Oh, okay, so the Hex Bug. No, there was another one I think that I bought from Radio Shack. Used to sell these little robots. I'm not sure if it was Hexbot or not now.
Oh, I was thinking Hexbugs, yeah, sorry about that.
Hex Bug. That's
Oh,
one that
Hexbug. Oh, how do you spell that?
HEXBUG. But wasn't that the one? Okay, I got one of those too.
Oh,
the one with the-
Hexbox. Oh, okay.
Yeah, these guys with the little
Oh, yeah.
like a
Oh,
spider one.
Hexbug, yeah.
That would straight across the floor with just the little rubber legs and a vibration piezo vibration.
Oh, yeah, I remember those.
Yeah, that's it. I have two of those, but the other one I'm talking about is more like a spider. That was from Radio Shack.
Oh, yeah.
Oh, wow. Thank you for pointing this out to me. I have to. Oh, you're on Target.
Yeah, here it is. Hex, or no.
Hexbot.
There's
I'm sorry, Hexbug.
Hexbug spider. That's very similar to the one I got at Radio Shack anyway.
Well, I'll have to look into Hexbugs. Thank you so much. Thank you, Jim.
Yeah, I didn't know if they were still around. I guess Radio Shack just sold those as a separate.
I wonder who bought Radio Shack. Oh, look at the one that was for the kids. That's really cool.
Oh wait, that's for the ones I have, the nanos.
Yeah, I need the. I'm a.
Can they pass each other though? Probably not.
I'm a total beginner at designing the one that the kids use. Oh, look how fun that is.
Oh, that's better than having them go across the floor and under the bed and like terrorizing the cat.
Oh, Nano. They're called Nano.
Yeah, the Nano. Yeah, I turned that on during the holidays and it would scurried off somewhere. And they bounced the ball. They hit something and they change direction. It's like a little robot. I mean, when it impacts, it automatically, I don't know if it's just the recoil, but it bounces and goes another direction is what ends up happening.
Oh, wow.
It's just a vibration.
Yeah.
And
the orientation of
The
those
shape of it,
legs
yeah, they go
pointed
forward.
back vibrate that makes it go forward.
But we used to make those out of heads of toothbrushes. That's where it started, right?
Oh, you
Yeah.
so you have been in robotics long before I was, so yeah.
Ouch.
I found my, thank you. I'm so happy that
Talking 2015.
X-Bugs. Oh, look at you. Thank you so much, Jim. I'm so excited. Thank you.
Yeah, no.
Oh, Jim, thank you so very much.
No problem.
Cool.
I didn't mean that.
Sensitive guy.
So hey, Sergey,
2015.
Sergey, what are you working on?
Yeah, that's when I started, really. Yeah. Well, I got the bug before that. But...
Sergey, good to see you.
Good to see you too. I was taking a break from my lawnmower just to play with Ross a little bit. Can you hear me?
Yep, I can see it.
Yeah, I've been reading your Ross, all your Ross stuff. It's quite a lot of it. The Turtlebot revisiting.
Well, I mean, it's a shame to have that nice create one platform and not to use it, at least to play with the latest incarnation of ROS 2. ROS 2 seems to be very mature at this point. You know, the current incarnation, current release is pretty stable. It's easy to use, good tutorials, easy to follow. So yeah, that was a nice experience. The only difficulty was to dig through this gyro assistant kind of the firmware on the create didn't report angle on odometry. So when the robot turns, it needs assistance from the gyro, which was the case with the original turtle. And, you know, I just made some little tweaks to the software to make it happen again.
Nice.
Anybody here has Create 2 or Roomba 500, 600 around?
Who used to work, Camp still does, but.
Well, I have the, I don't have one of those, but, Camp got me into the vacuum, the little vacuum, Nito bot back, which, they got that working with ROS 2 a few years ago. So I have one of those I have to get back to it with I have it with ROS 2. I gave you a demo here when I was just getting started. But ROS 2 running on a Raspberry Pi, 8 gigabyte inside the dust bin of the vacuum, and so that one there's a GitHub for that. It's been evolving. That's slightly different than the one than Sergey's working on, but that Nito botback is a pretty easy one to get, refurbished for $90, and you plug right into it. With the USB cable, and you can give it commands. Like who designs a vacuum like that? That's pretty cool that they did that. But yours is based on is it the Create? iCreate, is that or the one they use?
It comes from iRobot. It was released in 2013. Or around that time, or even earlier than that, I don't really know. But the point is that it was specifically designed to do the, kind of school competition or hobby built on top of vacuum cleaner platform. So it has DB22, 25 jack, the socket, and you can plug into it, you know, take 5 volts from there, take 17 volts from there, or command it through serial interface, serial TTL.
Wow.
Right, the iRobot, or iRobot Create. They originally,
Yes,
they
it
had
is
the,
called iRobot Create 1. They
they
really,
had the 1, the 2, and the 3.
that's correct, right. I happen to have Create 1, and it has that nasty odometry bug that, you know, kind of prevents it from correctly working with ROS out of the box.
Oh. So you fixed it though. You fixed it. You got a way around it.
Yeah, I made it work with a bit of tweaking the software, you know. Basically, I used the gyro almost the same way as the old Turtlebot was using it.
So is it fusion? Are you using? Is it kind of a fusion of the sensor fusion?
No, not really. The way it works, there is a stream from all the sensors coming from Create, and each 15 milliseconds, Create basically reports the state of all his sensors, which is about 15 of them. Bumper, you know, all the sensors and among that there is odometry setting, which is delivered as distance traveled and angle turned. And angle turned is always 0 in this particular firmware bug. So instead of, you know, taking that 0 and reporting it to ROS, I just take the gyro turn and report it to ROS as if it came from Create.
Oh, I see. So you're just redirecting from a different sensor, really.
Yeah.
Or that.
And I do it on the lowest level possible. So as soon as Create driver receives that information from Create through serial TTY, I replace that reading and it happens to work, you know.
That's good.
So Sergey, what is that very interesting thing in the background over there? It looks like a robot head on.
Oh, this one? Let me
Yeah.
tell you.
That caught my eye.
Yeah.
It's actually a Humpty Dumpty. And if I click the right switch, oh, I actually took the IMU out of this, so yeah, I need to put it back. But you can enjoy the lights show at least.
Yeah, that caught my eye.
Oh, there you go.
That's fun.
Oh, I like it.
Anyway, what I did with that is I took the hoverboard and I replaced the drivers for the motors with a different type of drivers that I bought from AliExpress, I believe, or Amazon, whatever it was. Programmed it with ESP32 in this case, and it's a balancer. It stays and it turns. I can hold the phone and command it with the twist of my hand to go forward or to turn, just kind of a little experimenting with balancing idea.
That's pretty cool. You built a lot of balancing robots before. I remember. didn't you?
That's my little, hobby. I like the idea because, first of all, they're very energy efficient. They don't waste batteries that much. Balancing doesn't take that much energy. And the second, they behave very well around the people because you can make them very tall and they are kind of moving in that small footprint in the crowd. So if you can make it stable, reliably, kind of holding the vertical position and not to be falling every 5 minutes, that's a good demonstration. That's a good kind of telepresence robot. I mean, you saw that on TV in some cases, in different presentation. It's impressive.
Yeah. Pretty cool. Thank you for showing us up, Sergey. And good seeing you.
Good seeing you too, guys. I'm in Alabama now, and I'm enjoying my retirement, obviously. And it's a good life, so I'm enjoying building robots and taking care of the property and traveling around. So I don't wish everybody to be that old, but I wish everybody to be that free.
Definitely. Okay, so anybody else have anything to show for show and tell? If not, then we will call this the end of the meeting. And we'll see you guys next month. Thanks everybody for coming.
Thank you so much. It was nice to meet everybody.
Yeah.
Thank you, Sergey, for showing us your beautiful presentation too.
All right. Thanks, everyone.
See you next month.